Oh, damn it, I always do this. 2. Okay, you do not meet the minimum requirements to use this feature. Whatever. Update. All right. Hello, everybody, and welcome to the stream. My name is Nick Larson. Happy Thursday. Today is October 3rd, 2019. It's about 12:02 in the afternoon. We got started just a little bit late, but we're going to get rolling here. So today we're going to get back to what we were working on yesterday, which is writing a model, building a model, learning a model to teach or to predict the developer role for a job based on the tags and probably the title. I think maybe we'll get to later on today as well. We're going to be working, we're going to do some pair programming today. That's also what we're going to do. I'm waiting right now on Jason Punyon to show up. Once he shows up, we're going to go ahead and get started. But in the meantime, we're just going to hang out. I would like to go ahead and throw a bunch of shout outs to some people who followed me yesterday. Forbidden Masood, Fobden Masood, I'm trying my hardest here. The Foz Smoke, Zazarus, Ablaze, and Hadger11. Would like to say thank you so much for the follows. I really, really appreciate that. And yeah, we're going to get started here. So just to sort of cover, actually, before we get into that, let's see. I want to introduce a little about what's going on. Okay. Yeah, so conceptually here, let's take a look. We want to go new one of these. Pop it over here. All right, when you go to Stack Overflow and we go to /jobs, there we are. All right, what we have is a job like senior applied data scientist that it thinks I would, like to see a yellow box for. Okay, and this is for a data scientist. So this is the role that's on the job. And then we also have these things right here, which is the tags. And then also up here we have the title, right? From these things, can we decide what role this should have? And there's really maybe a dozen roles, 12 roles, 14 roles, something like that. They're like data scientist, full stack developer, front end developer, back end developer. I don't even know what else. Probably DevOps somewhere in there. There's a bunch of them. And so our goal is really just to figure out a way to predict these. Why do we want to do this? Well, it turns out that a lot of the jobs on Stack Overflow get posted through our API. When they get posted through our API, they normally come from third parties, not the actual company that's doing, that's hosting the listing. So this would be like a syndicator of job listings. And what they do is they're like, we want, this one field for this and this one field for this. Like I want the job description and I want the whatever else. And oftentimes they don't come with everything. Specifically, this role is a field that is specific only to Stack Overflow jobs. So what we need to do is we need to figure out some way to automatically fill this out from the information that we see that that is provided to us. Currently, we have 2 people on staff full-time whose job it is to look at all of the jobs that come in, make sure that they are tagged appropriately, make sure they have the correct role, and make sure that overall they're in good shape to be able to perform well on our site. And it's like we want to help them out. That's really like what the goal is here. And so today, that's what we want to do. We want to get into building a model that can predict which one of these we should do from these. And how this works is we have a tool already that predicts these using all of this and the title. And it tags it. And then once it's done with the tags, then we want to use the title and we want to use the tags to figure out what the role should be. And that's pretty much it. That's what the goal is for today. So we have started a little bit. Yesterday I went to our database and I grabbed some jobs and the information that we care about. Right? So what we have is the tags that are on it, We have the job ID itself, we have the tags that are on it, and then we have the roles. And in each of these cases, like there can be more than one tag. So this one has 4 tags right here. And then there can also be more than one role. If we go a little bit down, can we find... Oh, here's one. Mobile developer and data scientist. That's pretty crazy. I'm actually kind of interested in that one to see if it's even correct, because those two things are not exactly related. Did not find it. Oh, it's because I'm not logged in. So these are from jobs all time. If I scroll down to the bottom, we'll get the more recent jobs, I think, or not. I don't know, maybe. But I can see all of them when I'm logged in. So this is what this one looks like right here. If you can see that. And this is, we are looking for an exceptionally talented, hungry senior dev with a versatile tool set to drive the release and evolution of a globally scalable first-class product. Oh my. Hey, what's up, Frackberg? Good to see you. How are you doing today? Alright, you will enjoy a wide variety. Oh. Now I'm losing things. Alright. You will enjoy a wide variety of responsibilities and report directly to the CEO, giving you a high level... Hey, what's up? Can you hear me? Yeah, you're not going to be able to see me. You can follow... you can go to the Twitch page. Jason's on the line. We're going to get him set up. Guy I'm pair programming with today is a co-worker of mine who I have been working very closely with for nearly a decade now, and he's going to show y'all how to do all the stuff I tried to do yesterday, but he's going to do it a lot easier. Basically. Let me see if I can get... Well, he doesn't think that's true. Let me switch this up so that they can actually hear you. All right, talk one more time. Uh-oh. I'm going to have to rejoin the Hangout. I'll be right back. All right, go ahead and talk one more time. Oh, man, what is this causing? Everything's always broken. What I'm hearing. It's supposed to be what I'm hearing. Okay, well, we're going to do the settings thing. I'm good. I made a functional thing in JavaScript. Yeah, if you want to watch the video, man, you can hop over on the actual stream page and then just turn the volume off so that I can't hear it. You'll also be able to see the chat if you do that, which people will ask questions at some point. Oh, yeah, that's a good question, actually. It's this URL. Chat? There you go. No, I couldn't get Fody. They don't let you have 4-letter names. Oh, really? Oh, interesting. I tried to change to that name and they told me that I couldn't have 4-letter name. It's on the video. Hey, Relevant Jesse, thank you so much for the follow. What I'm... No. Working on it. No, we can at least solve that problem, can't we? Let's do, window capture. You don't need a green screen. Create new. Pairing. Recovered from TwitchCon and back to work. Yeah, pretty much. I'm trying to get all this set up currently. It's going to be just a moment. Kasukin, thank you so much for the follow. Meet. Why is it not letting me capture this? Yeah, I mean, it feels like that sometimes, but no, this has worked before in the past. I don't know, maybe if I just click OK. No, it's a freaking black box. Okay, we're just going to make you full screen and we're just going to share the whole screen. Okay, we made it full screen. Let's kill this because I don't want that. Delete. Yeah, I want to remove it. There we go. Is that what it says? When you're logged out, that's weird. Window capture. I don't want window capture. I want like a whole screen. Game capture? Capture any full screen application. Capture specific window. Window. Working on it, working on it, working on it. That would have been way too easy. How do you capture a whole screen? Video capture device. Nope. I haven't done this in a while. I did this with Juan not too long ago. I'm just like at a loss here. Okay, let's go to full screen. And I want to whole screen middle. Okay, how is this one set up? Properties. Display 1. Sorry. I'm just gonna try them all. I'm sorry, if anybody in the chat knows how to like share an entire screen, if you could just how to like capture it in OBS, I would really appreciate that at the moment. Yeah. No, it's just like literally not doing it. Cancel, delete. Okay. I just can't figure it out to save my life here. It's like not even telling me what it is. Display? Can I copy this? That would be great. Can I duplicate this? Transform, copy. Oh, what's up? What's up? Now I can paste, right? Paste. I don't want a reference, I want a duplicate. And it won't let me paste a duplicate because that would be way too easy. Display capture. Oh my god. There we go. Okay. Screen 2. That's it. Alright, there's you. Now let's shrink you. There you are. Okay, alright, we got this. Yeah, okay, we are making progress. Holy shit, that's all it took. It just took like an hour. Mute what window? Oh, how about that? I think you need to mute yours, yeah. Okay, keep it like this. Okay, that take. No, I'm working on it. Yes, I do. Audio. Audio. Maybe I just have this one like what I'm hearing. Maybe it's just set up wrong. Nope, hold on. Okay, one more time. This usually works. Um, Senseheimer main audio. Wait, what if I just turn the volume up? Try talking now. Advanced audio properties? No, that's not what I want. I want properties. Okay. Well, all right, we're just gonna add a new one. Audio output capture. Okay, try it now.
Check, check.
Oh, there it goes. Okay, I know they can hear that.
Oh!
All right, is it too loud? Try it again. Can you? I can't actually. I can only hear you through my headphones. I can't tell whether or not
Yeah,
it
no, I got the loop coming back on the Twitch stream and I hear myself.
is. It is it a
A
good
little
volume?
quiet.
Turn
A
you up
little
a bit
quiet.
here. How about that?
Oh, wait, but maybe I'm just quiet. Maybe my volume is quiet. That's why.
I mean, relative to me, that's all I care about. No? Okay.
All right, I
All
think
right.
we did it.
All right, yeah. All right, if you're in the chat and you would like to, me to play with the audio properties a little bit longer, by all means, let me know. And let's go ahead and get started. So first, let's talk about Jason. Well, Jason, welcome to the stream. Thank you so much for joining me today, man. I really appreciate it.
Yeah, I know. I know you've been doing this for a while, and yeah. I
Yeah.
hope everybody likes my Linux Penguin hat. This is actually my son's.
Oh, yeah?
Yeah, but I stole it from him a long time ago. So,
I mean, that was a solid choice.
yeah.
Okay, so let's talk a little bit about you. I mean, how long have you? So we've been working together for quite a while, almost what 9 years at this point, and I mean, goodness me, it's just a long
Yeah.
time. Yeah, it's just a long time. Yeah, I guess tell us, a little bit about yourself, whatever you feel comfortable sharing, and don't feel obligated.
Yeah, of course. I've been working with Nick for, like you said, 9 years. I started at Stack Overflow about 9.5 years ago, and then like 6 months later, Nick started, and we worked on talent together for a bunch of years. Well, back then it was called careers, um, and so like web dev and all that goodness on the Microsoft stack. And then we sort of parted ways a little bit for a while. I went off to do this
That
whole
other thing.
yeah, that other thing. I went off and did. I took a brief stint in management that I failed at horribly, um, and I was running our ad server team for a while there, and that didn't work out. And about 6 months into that not working out, another friend of ours who works at the company, Kevin. I don't know if you talked about Kevin at all, but Kevin,
Not really, but yeah,
uh,
Kevin is our boss, in a sense.
Kevin is our manager.
Yeah.
Um, he doesn't tell us what to do, but he's our manager. Um, Kevin asked me to start the data team with him at Stack Overflow, and we started the data. Kevin and I worked on the data team for about a year, um, more than a year, and you were still working on talent then.
Yeah, I was on talent for 4.5 years almost
Yeah.
from when I
Um,
started. So where we are in the timeline here is like, yeah, probably right around that time, maybe a little bit before. I think y'all did a couple of people came onto the team like before me, so it
yeah,
wasn't.
but then they left.
Yeah,
Then they left. Or wait, no, Dave on the team when you got to us?
no, y'all had already been through the interview process with Dave, but Dave didn't join until maybe a few months after I started.
Yeah, okay.
Yeah,
So we're talking about Dave Robinson, data scientist extraordinaire, teacher of both me and Nick about
very much
um,
so.
ev basically everything we're gonna probably talk about today. I don't know exactly what we're talking about.
Well, we'll get
You
into
just
it.
to, you told me to come to the stream this morning. We're like, yeah, we're gonna talk about some stuff.
Yeah, I was like, well, that thing we did yesterday. Anyway,
Yeah. So we've worked on the data team together for probably what, 4 years,
it'll be
three and a
five.
half,
Yeah,
three.
yeah. No,
What were you? You started in 2015.
it's over four at this point for sure. Yeah,
Yeah. So 4 years we've been working on the data science team at Stack Overflow together. And Yeah, I live in Buffalo. Um, Remote work is awesome if you can get it. Um, yeah, this is my first Twitch stream.
that's cool. All right. Well, let's talk a little bit about about what you do. So you're on the data team. What is your like roles and responsibility? What are some projects that you're like super pumped about, or rather, let's talk about the past first. Let's not talk about the present. Um, what are some things you
Okay,
that you have accomplished and you'd like to share?
sure. So data team, our first foray, before we had any data scientists, and it was just me and Kevin who had, some math skills and some very minor data skills, I think. We're trying to solve the problem of targeting jobs on Stack Overflow. And There's a whole I sort of have a blog post about.
You should be able to drop links in the chat if you've signed up. If you haven't, you can paste it in chat and I'll drop it for you.
Okay, sure. I wrote a sort of bunch of blog posts about it, and Kevin wrote a bunch of blog posts about it. But and I oh, chat rules. We're all learning here, so stay positive. Please share any ideas you might have. All right.
Oh, did you sign up for the full Nick Larson experience?
I don't know. Oh, wait. No, I tried to post it. Okay, sign up. Can I sign up with just like, can I log in with Google? No.
That would be
All
way too
right.
easy.
Facebook. Fuck that.
Hmm.
Oh, wait. Apparently I have an account here.
Crazy.
Log in. Oh. Chat. Log in. Log in.
Why don't you
Is
just
that
drop
me?
me the link?
Uh-oh.
Just drop me the link. This will go faster.
Uh-oh. Wait. Now. Post it. Oh,
Hey, all right,
yeah.
there you go.
Yeah,
Failure
so
is
that's
always an option.
yeah, this is the big blog. This is a big blog post about it. The one that I think got the most views of any of the six that Kevin and I wrote about it at the time. But we were trying to. Then there's links to the previous blog posts in there. Oh yeah, that's my that's my awesome paper art about what we built.
Hand drawn things are quite popular around here.
Yes, these are not freehand red circles. These are freehand Providence architecture. So we built this thing called Providence, and Providence sort of tells Stack Overflow what kind of jobs that we're currently uh, serving that you might be interested in as one of our end users. And we use this to talk about. We use this to you got to pop open stackoverflow.com and show the ads.
Sure. Oh, wait, I'm not going to be able to do this until I like turn off my pie
Ad
hole.
block.
Yeah.
Oh,
Hold
you
on.
son of a bitch! You block our
Yeah,
ads.
I sure do, man. I think
Yeah,
that's a
that
solid
might
choice.
that might be the right answer.
I might recommend that to other people as well. Pie.hole, right? That's what it is.
I
There it
don't know.
is. Yeah, let me
I don't
go.
have a pie hole.
Log in. You should get a pie hole. Nah, I mean, do whatever you want to do. But I like the pie hole. It's pretty simple. There's a nice little interface for it for like managing things quickly
Uh,
when you want to do that, like this. And now I can go to, like, I don't know, let's go to stackoverflow.com. And maybe let's go to a question page. And maybe let's go to a question. Oh, look at that.
all right. So what jobs do we think Nick's interested in?
I'm not logged in.
Um,
This is me anonymous.
oh, you should log in so we can show people how good it is.
All right. Let's go to a question page. Now it actually wants to show. Oop, that was dangerous. Yep.
Oh, you
Gotta
are
be
logged
super
in
careful
now.
about that. Hey, there we go. There's some jobs. What does it think
All
about
right. What do
me?
they think? What does it think about you? Senior lead full stack .NET developer at a fast growing cannabis startup. I mean,
That
that sounds like you, my
sounds like
man.
me.
um, full stack .NET C Sharp software developer, backend engineer, Node.js for consumer products and automotive enthusiast space. Well, full stack
I
developer
don't
with
want to.
React
I
and
don't want to brag, but I did take automotive technology in high school in ninth grade,
the man knows how to change an air filter.
and some tires, and some oil. I can even change your you know, washer fluid.
Make sure washer fluid, you idiot. It's the blinker fluid.
Oh,
That's
the
the joke.
fluid. Sorry.
Your blinker fluid, your exhaust bearings. Larson knows all about it. Yeah, so I mean, we think this is a demo of our tech. It thinks he's so what ASP.NET MVC, C Sharp, JavaScript. I mean, that's kind of what we deal with. Everybody's got a little JavaScript on them, so that's why that
we
JavaScript,
we should
those
point out that
JavaScript
it also
jobs are
hit me
there.
for remote here.
It hit him for remote.
Yeah.
It also hit him for it might hit him for the salary ranges that
Oh, nah,
he
goodness
cares
me.
about. So
Maybe
maybe we're exposing a little bit more about Nick
it's all
than
right.
we think, and that's true of all ads. If you ever see any what ads anybody is choosing for you,
Tends
it
to be
is
a.
it's a life affirming experience.
It absolutely is. Oh wait, I got to put your face back on there. Wait, there we go. Everybody was
Oh
looking at the
yeah,
pie hole,
there I am. Now they're
which is
just looking at
roughly
the
the same
asshole.
thing.
Now they're looking at the asshole.
Yeah.
Okay. So yeah, and if he F5'd again, you'd probably see some more C sharp jobs and probably a little bit of JavaScript and things like that. Uh, Waiver
C
job
sharp, yeah.
anywhere near you? Anything near you?
No, I think I'm pretty hard on the remote thing.
Yeah. Well, if you ask for remote, we do push a lot of remote.
Yeah.
And you could see that. So if you went to your if you went to talent, if you went to jobs right now and looked at
No, I'm not gonna do that.
your All right. So yeah. So that's a big thing that we worked on at the beginning. Other things that we do on the data team include so we have this data team request process.
Hmm.
I think that's big for us, which is the way that other people at Stack Overflow ask us about things that they're interested in. And we use our our own Stack Overflow internal team to sort of triage and handle those requests. And I think we do a pretty good job at answering those
Yeah, I think so.
for people who are not on the data team but want data team resources. We play a big consulting role within the company. So we try to we have our own ideas about the things that we should be doing and what we should focus on, and then through this data team request process, we consult to the rest of the company. So that can be from our business units, the people on talent who need to know how our job's doing in various areas, and targeting and stuff like that, to our community. How do flags work on Stack Overflow? Who's getting flagged? Is that appropriate? To finance, where we talk with the finance people at our company about what our data says about their finance situation. To I don't know who else. SRE.
Lots of
I think
stuff.
we could sell a little bit less with SRE, but when we get involved with SRE about our data, we have tons of SRE data around when things go wrong. We have our bosun
Right? Can I get to
sort
that?
of
I probably shouldn't.
bosun.ds. Yeah, I mean, I don't think that there's nothing customer specific
It's.
or
I just want to do it off screen here in case something comes up that I shouldn't. Let me see if I'm actually on. But yeah, go ahead.
Sometimes I think me more than anybody else helps dig into the data issues around some of our outages, and how could we predict future outages? What were the signals that could have told us that this was going to be an outage? Um, those tend to be not so much like long-term things, but like, hey, we're down. Let's figure out how we're down. So in the past week,
Here, give me a
we've
metric.
had
Let's look at something in the past week.
um, sure. So if you want to look at something in the past week that was a big deal, you could look at os.proc.mem.
Real?
Real.
Where am I looking?
And the host would be ny-ml redis star, or sorry, no, ny redis star. No, ny redis 02. Look at ny redis 02.
Okay. And you want like a week?
Yeah, our bugs were last Friday and Monday, I think.
Okay.
But there should be some interesting stuff in here. Okay, so last Friday, we had see that giant spike?
Whoops.
Yeah, Redis flipped out on Friday, um, and we had problem. There was sort of, oh, what was the final answer on this one? It was, I think we had, I can't remember. There's been a couple of Redis problems, as you can see in these giant spikes here. The one on Friday was huge. The one on Monday was less huge, but still there and real.
Mm-hmm.
So these Redises keep track of all of our profiling information on Stack Overflow, and they were acting up for various reasons. I know who was interesting about this. Nick Craver tweeted a bunch about this. He's one of our SREs.
I'm not sure I would call him an SRE. We got to give him the credit of being the architect here.
I mean, I don't know if he would actually appreciate that credit,
Well,
but he has posted a bunch about recently about some of the problems we've been having and stuff like that. So on Friday, on Monday, on the Monday's issue was we had a 5 MB key in Redis. That's a new key in Redis that started blowing up. Stack Overflow was trying to request that key once an hour, and we sort of had a stampeding effect on our Redis server, and we ate, I think, about 100 gigabytes of internal bandwidth in over a minute.
yeah.
And that was taking Stack Overflow down for a few minutes every hour,
Whoops.
until we until we mitigated it, until we figured out what it was and then mitigated it. And stuff like this, Boson, I think is an incredible resource for us. It sort of puts us and SRE on the same level, in that we can help deal with their problems because they publish their data to us internally so well, and so
Right.
we're able to correlate and figure out where all the problems are.
Yeah, I would
Um,
say that the number of times that this tool alone has helped us find the actual root cause of the problem is like I can no longer count that high on my hands.
yeah, or my feet,
Or
or if
yeah,
I had 10 people's fingers and toes.
yeah,
It's my saying is, if logging is not solving your problem, you're not using enough of it. Um,
it's good.
uh, Log everything. I know it's sort of an SRE problem. Like, where are all these logs going? Hard disk space. Like, it's a big problem. But systems like Boson, and I think we're looking at or have switched over to this thing called SignalFX. I have not looked at it yet. But anything that's able to monitor the sort of bulk properties of your system, like how much memory are you using, what's your request, how long are request times taking,
Yeah,
all that kind of stuff is, it enables me to do amazing stuff for the SRE team here. that I wouldn't be able to do otherwise because there'd be no data.
Yeah. Like
Um,
this sort of thing would be much more difficult to debug and to sort of figure out. So yeah. All right, well, let's keep moving on, man, because
yeah,
what are you working on now, if you don't mind? Whatever you're allowed to talk about, whatever you want to talk about, and what are you looking forward to in the future here?
sure. So, big things I've been working on over the past year at Stack Overflow are our so it's called internally it's called the unfriendly robot.
Okay.
Um, Externally, we call it the unfriendly comment classifier. About a year or so ago on Stack Overflow, we realized because people told us that um, that their experience wasn't as good. Their experience wasn't good because of comments on Stack Overflow. And commenting on Stack Overflow is one of the most frequent operations that happens on Stack Overflow. So over the lifetime of Stack Overflow, there have been 100 million comments. If you want to compare that to the number of questions or answers, Stack Overflow has, I think, about 20 million questions right now,
Yeah. Uh,
and a larger number of answers.
19?
Um,
Yeah, something like that.
19 or 20 million comments on, sorry, 19 or 20 million questions on Stack Overflow, 100 million comments.
We have
Um,
18 million, 18.3. Well, public anyway.
yeah, so I'm talking about, yeah, so there's stuff that you can't see there anymore because those questions have been deleted,
Right.
or flagged off the site or whatever. Um, One of the things that we started working on was comments and how to detect unfriendly comments on Stack Overflow. Um, it has been a long slog, but last year there were a number of improvements or breakthrough improvements in natural language processing.
Right.
And specifically, I work with Fast.ai, which their model is called ULM Fit,
Yeah.
um, or Universal Language Model Fine Tuning.
Oh, interesting.
Um,
Wait, so
so the
no, go
Go ahead.
ahead. No, keep going.
The idea is that you can learn a lot about language from Wikipedia, and how can you apply that language to your own uh, um, natural language problems that uh, may not may not be exactly like Wikipedia, but because of the commonality of English and stuff like that, you can transfer what you learn about the English language from looking at Wikipedia um, to looking at unfriendly comments on Stack Overflow.
Interesting.
Um, so these people are fast.ai. That's the website. Um, they run a fantastic MOOC about about all kinds of machine learning that's mostly focused on neural networks, and they use so the big two sort of neural network platforms right now are TensorFlow and PyTorch,
Hmm.
or Torch or PyTorch or that whole side of things. Um, and but these people package up their software very well and make it easily runnable for you. And they also have a course that is all about how to use their software to do various things. So I think their first lesson is recreating hot dog, no hot dog. Um,
I don't know what that is.
in So Silicon Valley was the one of the jokes was Jin Yang makes uh, an AI focused app that tells you whether the food you are looking at is a hot dog or is not a hot dog.
Interesting.
Um, and so so they talk about how to make any so hot dog not hot dog is an instance of binary classification of image data, and Fast.ai a you can create a binary classification for any kind of images that you're interested in, and it might possibly work.
Okay.
And it will cost you very, very little it'll cost you very little in terms of dollars, and it'll cost you very little in terms of um, like dependencies and learning about the software because they do such a good job at
Right.
at teaching you exactly how to use the software.
Okay, but
So
like when it comes to getting models like this, and especially with transfer learning, at least in my experience, you sort of get what you pay for a little bit, but I recall you might have had a little more success with it than I have had.
yeah, so I haven't been working on images. I've been working on text
Okay.
data or natural language data.
Right, the comments.
Um, yeah, the comments. So in our first in our first deployment of the unfriendly robot comment classifier that I created, we ended up finding out through our so what happens? A comment comes on Stack Overflow. The model gets consulted about the comments that are on Stack Overflow, and then we raise flags automatically for our moderators to deal with. Um, you can look at the accuracy rate of that flag compared to the accuracy rate of flags that are created by the humans who are doing flags on Stack Overflow. That's sort of the benchmark that I use. So human flaggers on Stack Overflow are between 60 and 70% accurate.
So
Um,
accurate in this case meaning accepted flag versus declined flag.
yeah, so the moderators get a flag that comes in, and then the moderators, based on our rules and their personal feelings and whatever else they put into it, decide whether the flag that was raised is accurate or not accurate, or helpful or not helpful. And so humans can raise unfriendly flags on Stack Overflow comments, and the robot can raise unfriendly flags on Stack Overflow comments. And when you look at the accuracy of the humans versus the accuracy of the robots, you can tell, you can sort of benchmark how well your machine learning is doing.
Okay.
And so humans are about 60 to 70% accurate. Our first run of the unfriendly robot on Stack Overflow was 40-ish% accurate, so not nearly as good as humans. Um, and so we collected more data, and we retrained our model after that collection happened. And currently we are sitting. I'm a severe pessimist about machine learning uh, and how good it's actually working for you at any time. Um, but I have done a lot of digging into this area of our site, um, and it seems like the machine is doing very, very good in our second version. So it is currently more accurate than humans, flagging unfriendly comments on Stack Overflow at about 75% accuracy,
That's incredible.
which is incredible. And you shouldn't believe me unless our friend Dave Robinson used to say, extreme conclusions require extreme evidence.
Right.
So the idea that we have a superhuman level machine learning model that is flagging unfriendly comments on Stack Overflow, that's a thing that would have been unheard of even 2 years ago.
Right.
Uh,
Right. So
and
I
so I've spent a whole bunch of time digging into like, are the flags that are being raised by the robot on Stack Overflow actually that good, or is there some um, on our data team we call it degeneracy, where maybe you made the model overall better, but you did that um, by creating problems for a subset of your users, a specific subset of your users.
right.
Um, like so on Stack Overflow, you might talk about it as new users versus old users. Are we like, if the robot is flagging a whole bunch of stuff from new users and saying, "Oh, it's all these new users who are the problem," where the human flaggers of Stack Overflow might have a completely different opinion. That would be like our robot saying something like, well, it's all the new users. If the humans aren't saying that, is sort of an indefensible position. Um, or things like that. So we look at if our models are particularly disadvantaging any subpopulation of our users against any other subpopulation of our users, and the results have been pretty good.
That's good.
We haven't found anywhere where the robot seems to be acting completely out of line
Right.
um,
So I want to
about
take a
any
moment.
particular thing.
I want to take a moment. I just want to kind of quantify this problem for people who are watching. First off, I want to note that I was very recently at TwitchCon. I had a great time there. Super fun. It was a really good conference from my perspective. While I was there, a number of people had come up to me, and one in particular came up to me and literally was like, "I don't go to Stack Overflow. Well, recently I've noticed that it's been a lot better." And I was like, "What do you mean by that?" And they're like, "Well, it used to just be when you would go, there was just nothing but like troublesome stuff everywhere, especially on the biggest posts, the ones that you go to the most." And recently I haven't been running into that as much. And I was like, I know the guy who had a lot to do with that. And here's Jason Pine, but I want to quantify like numbers wise, how many flags were being generated by humans, and how underflagged was Stack Overflow?
Sure.
Just
So
ballpark numbers.
yeah, after some research that we did last year in having humans rate a random subset of Stack Overflow comments that we presented to them, um, on another website, on like we built a little app that sort of just displayed comments to people and said, "Hey, do you think these are friendly or unfriendly?" I think we used emojis that were like, I forget which emojis we used, but
Smiley
it was
face
like
or
smiley face was okay, and then like the Stephen Colbert
yeah.
like eyebrow raise emoji was the maybe something's a little bit wrong here, and then the outright like rage face, red face, like covered over with the black bar and symbols emoji was the like somebody's being really really abusive. Um, and we wrote up that research. Let's find at stackoverflow.blog. Um,
Look, if I move you over here, it'll look like I'm actually looking at you.
oh,
What's up?
wait, do I have to do?
No,
I
you don't
guess I have
have
to
to
go
do
like
that.
this.
It's just easier for me.
Hey, Nick, how's it going?
No, you're fine. Wait, you have two monitors, don't you? Just move it over there.
Move it. I'd have to move it
Don't worry
over
about it. I was
here.
kidding. I was kidding.
Let's see if I move it over here. All right, now we're talking to each other.
It's a little weird though, because no one's looking at the people who are watching. I don't know. I'm new at this.
um, another one of our colleagues, Dr. Julia Silgi, and I uh, decided to present comments to people and figure out how many comments people thought were really unfriendly or abusive, and um, and what we found in that research um, was that the all of the cohorts of people decided that the people who thought Stack Overflow was the least unfriendly still thought it was about 3% unfriendly when they looked at their comments.
Okay.
Um, People sort of closer, the more experience you had and the closer you were to the company, we tested a few different populations. And people inside the company thought comments were the most unfriendly. People who are very close to the company, but who are moderators and things like that, were next. And then the people who were furthest away from the company. So we have a research list, which is like, hey, if you ever want to be involved in Stack Overflow research, just let us know. Those are people who maybe don't have accounts or stuff like that. And what we found was that a lot of comments were more unfriendly. A lot of people thought a lot of comments were unfriendly, and they thought that more comments than we were actually finding through our existing flag process were unfriendly.
Okay.
Um, so the existing flag rate on Stack Overflow was very low, much less than 1%,
Okay.
before we started our work. So this is very recent um, work. So in July, we let the robot out, to start flagging comments in the wild. And let's see, I guess I can maybe share this. All right, where did that other window go? This one. Share, present a window. This one. So I don't know if you want to make that bigger, Nick.
Oh,
Uh,
yeah, yeah, yeah.
so this is part of a report that I've been running on the robot, sort of periodically. V1 of the robot ran from July 11th to about September 15th, and V2 of the robot has been running since September 15th. What we found is, so version 1 of the robot was it was not good on false positives. It was producing a lot of flags that people thought were not unfriendly at the time. And you can see that, so these metrics here are human flag count, human helpful flag count rate. So during V1, which was about 2 months, humans raised 4,000 flags, of which 62.4% were deemed helpful by our moderators. During that same period, the robot raised 15,000 flags that were seen as helpful by the moderators at a rate of 43.9%. So it was generating a lot of false positives, but the detection improvement that we had was, so detection improvement is how much more, if human level flags are detecting 100% of the problem, this is how much more on top of that we're detecting now because the robot is running.
Okay.
So while the helpful flag rate was low, we were still ending up finding about 3 times more unfriendliness on Stack Overflow than we had before. So at the end of V1, we worked out what we wanted to do for V2, or what our problems were, and we said, well, obviously false positive rate is the problem. When the robot is generating 4 times as many flags as humans, and our moderators have to deal with them, we didn't want to be dumping a whole bunch of stuff that was not unfriendly into the unfriendly queue. And so we worked on it. At the beginning of September, I retrained the model, and reworked the model. And what we found, we've been running that since about, like I said, about September 15th.
Yeah.
And we have so the current situation is, so since September 15th, humans have raised 1,200 flags at a helpful rate of 67.2%, and the robot has raised 4,500 flags at a helpful rate of 74.5%, about 75%. So the robot is now more accurate than humans in flagging unfriendliness on Stack Overflow. There's a bunch of, so again, degeneracy passes. Like, are we hurting any subpopulation of Stack Overflow? Not in proportion to their, like, is the robot saying something that is proportionately different from what humans say?
Right.
These summary statistics look really good, right? Like superhuman level classification performance. But it could be that it is, like sometimes you train a classifier and yeah, it's 99% accurate, but it's because it's always predicting a 0.
Yeah, yeah.
Or something like that. That doesn't seem to be the case here. The rest of this report goes into like,
Sure, we don't need to get into
is
that.
it? Yeah, but so basically now our current state is these numbers came out this morning. So we're detecting 405% more unfriendliness on Stack Overflow than humans alone using the robot. And to do that detection, we raise fewer flags than humans would raise to detect that
Right,
level of the problem because the robot is more accurate than humans, it
right.
appears. I'm a pessimist. All the rest of this report says, like, here are things that I've looked at and don't appear to be a problem with the robot. But I have not looked at everything. Things could be better. Things could be worse, depending on sort of the lens through which you evaluate things.
Absolutely.
Um,
Uh,
so I've tried
so
to evaluate it through a lot of lenses, new users, whether the flags are on questions or answers, or whether we're flagging the poster more than other people who are kind of interloping through and maybe drop of an unfriendly comment or something like that. And it appears that through all, I have not found anything in my investigation that has led me to believe that the robot is doing something untoward in order to get its accuracy improvement or anything like that. And that's a really important thing to do when you deploy machine learning into the real world,
absolutely.
um, because
Accuracy
it's
isn't the only measure.
accuracy isn't the only measure, but it's also the focus on the people, like the people who are the subject of my machinations. I feel like if my model is not doing well, then I am doing something unethical um, to them by allowing my model to run. Um, and
Right.
so all of this kind of stuff is very important in making sure that we're not Stack Overflow is not going to export a whole bunch of badness into the world. We're very big. Um, we have the ability to make things um, very bad for a lot of people if we do it wrong. And so I'm very focused on the human aspect of how our people are treated by the machinations that we create.
Right. So let's go ahead and talk about that then. There are some other like human considerations here. First off, being that like these flags aren't just like auto accept flags. Like these are still going through real humans.
Yes.
Yeah.
Uh, that's yeah. So we call and everybody calls that I guess um, human in the loop machine learning. Oh, now I'm gigantic.
You are a little gigantic.
Down there. um, so yeah, so we don't like to release machine learning into the wild and just have it run wild without monitoring, without anything like that. So on Stack Overflow, we have moderators, and our moderators deal with and handle all of the flags that get generated by humans and by robots. So their job is um, their job is hard, and we like so part of reducing this false positive rate that we wanted to do in V2 is about making those humans' lives better.
Yeah.
Um, because if we just let our machine learning run wild, we'd be generating 60% too many flags. Um, uh, and we don't want to burn those people out or anything like that.
All right, let's just
Uh,
one more thing about this, and that's it, and then we'll move on to something else. But
sure.
and also, yeah, not a one person show here. Moderators involved. There was also people internally that started advocating for this. This work had been going on for a while. It sort of got dropped off, got picked back up. Thank you to literally everyone involved with this. It has been a wonderful thing, and I just want to one more time go over and say like how much has been cleaned up. Like how many comments were there, and how much less negativity is there now?
Okay, so yeah, so that's detection improvement. So during the months that the robots have been running, during the first 2 months, we cleaned up 300% more stuff than we would have cleaned up. Let's get an actual number calculator. So 277, sorry, 2.77, 3.77, 3.77, yeah, 3.77 times 3961 times 0.624. So in our first month, we caught 9,000 flags. Where if only humans were running, we would have caught um, 61 times 0.624. We would have only caught 2,400. So
Right.
in those 2 months, we found about 6,000 extra unfriendly posts that were posted during those 2 months. So we made Stack Overflow that much better during that time. In the intervening almost 1 month, we have done a better job. 1251 times 0.672. So humans found 840 flags. 4574 times 0.745. So humans found 840 flags. The robot found another 3,500 flags.
Okay.
And that's in. We haven't even run a month yet on the new model.
Right.
So so our original hypothesis of like things are being underflagged is being proven out by what's going on here. Um,
Yeah. So
and yeah, and so we have ideas about. So we've only been running it on like this current 3 months of data, and trying to stem the tide of new stuff, of new unfriendliness coming in. We're also talking about how to go back and deal with, well, we've got 10 years of posts and all of that stuff beforehand and 100 million comments that we have to deal with. How are we going to go back and clean all that up as well?
yeah.
Is a thing we're thinking about, and also new ways to use this human level unfriendly finder. Like, should we be telling people as they're writing their comments, like, hey, we don't know how well this is going to work out? Um, because people might not even know, right? Like there's a very mimetic thing that goes on
I don't know what that
in
means.
comment. Mimetic is like the growth of ideas, I guess is the way I think about it.
Okay.
But that one person on Stack Overflow could say something like, well, Stack Overflow is not a free coding service. And maybe in that one instance, it wasn't so bad. But then other people glom onto that idea and say, like, oh, okay, in moderating Stack Overflow, it's okay to say things like Stack Overflow is not a free coding service. And again, right, like even me saying those words right here doesn't sound that unfriendly, or things like that. But when you see it in context, when our moderators see it in context, it takes on this unfriendly flair that we are trying to help out, trying to get rid of,
Yeah.
trying to deal with.
Right, and I guess the last thing to talk about here is it doesn't. So this robot that's out there, the way in which it actually grabs a hold of the comments today, not being preemptive about it, sort of some time has to go by. So there is still the experience for the user of like this thing shows up and you might see it before it's handled, but we're catching things a whole lot faster than we used to.
Oh yeah. Definitely versus humans.
Yeah.
I have let's see, I guess I can show this graph. Do, 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 do. I didn't do a very good job on this graph. But basically, if you look at the robot finds things within about the robot only works on things that are at least 5 minutes, that are 5 minutes to 10 minutes old currently.
Okay.
Um, so and it finds all this much more than humans are finding. Um, uh, I don't know. I just totally lost my train of thought and where I was going.
That's all right. Don't worry about it. Okay. You know what? Yeah, I mean,
The
like,
robot's fast. The robot's faster. There's stuff that gets found. The robot is faster and more thorough on on this very recent stuff. Humans touch Stack Overflow and they go back and they look at old answers and they come across old comments and stuff that we're not pointing the robot at right now.
yeah.
Um, and they find they're able they come across things that they think are unfriendly, that could be weeks to months to years old, that have just been on Stack Overflow forever and sort of constitute this long-standing problem that we believe we have, encoded in that hypothesis that there's way too little flagging going on Stack Overflow.
Yeah.
Um, we we got a pretty good. I think we got a pretty good handle on the current state of affairs and dealing with, like I said, stemming the tide of new garbage coming in. Um, and we want to point that lens at all of the old stuff that humans still come across. It's something like 20% of comments that get flagged by humans on Stack Overflow are comments that have been around for at least a week. And then if you, it's sort of like it scales off logarithmically.
Okay.
Um,
All right. Well, that was a very informative discussion, even for me as somebody who sits in the meetings to hear about this stuff day to day. So,
I know we don't get to talk nearly enough.
all right. So let's move on. Let's do some actual work since we're sort of at work here.
Oh, shizza.
We're gonna do my work because it's
Yeah.
my stream and my rules. No, actually, so this is sort of something that's like a bit of a side project to the thing that I'm working on. So what I am currently working on is replacing an old way that we used to build models on Stack Overflow for the careers product. On the careers product, originally, and if you go back and read these blog posts that Jason linked earlier, what you'll find is that we did what's called a bunch of tagging parties to basically say this job is this thing. And these tagging parties were like, at the time, we knew supervised learning, and that's what we knew, and that's what we had to do.
Labeling parties. We call
Labeling
them
parties,
labeling
whatever. Okay,
parties.
labeling
Yeah.
parties. Tagging part, whatever. Same thing to me.
There's tags. Tags are different than labels.
I don't care. I'm a millennial, right? I don't care about labels. Anyway,
Hashtag.
hashtag right. Anyway, so what we did is we created all of these concepts that are never seen on the front end. Okay? And these concepts are things like, are you a front end developer? Are you a back end developer? Are you a DevOps developer? Whatever it is that says a thing about this. And they got kind of specific in some cases, like I'm a Microsoft web developer, I am a PHP web developer, or whatever. And over time, we never like built in a way to sort of add new things as new things come on the market. And over the last 4 years, this has sort of led to some issues where we can no longer target some of the things that make up as much as, like, I don't know, 15-20% of our job board. Things like React. In fact, if you were to go to like Stack Overflow jobs right now and search for React, I would be not surprised in the least if you ended up finding something like, yeah, out of 4,000 jobs, 918 of them are tagged React. Like, that's a big deal that, like, we couldn't target that, right? So what we did was we said, all right, the way that we do this is we have a tool called the auto targeter. And this auto targeter was basically the thing that said, okay, once we had all of this data, we can take a job listing, it reads the text of the job listing, and it decides what tags and what sort of targeting features should go on to it. But we have no way to add new things to this auto targeter, and over time it's fallen off. So instead of having the auto targeter be the thing that generates the most important features, we said, what if we just ignore those features and throw them out completely? Can we do a better job? And that has been a very long process. That's what I've been working on for the last year or so.
Yeah.
Putting it lightly. And it hasn't been just me. Everybody on my team has had a good whack at this one, at different parts of it. I hate using the words. We learned a lot along the way, but oh my goodness, did we learn a lot along the way? It's been quite the experience. And then, at the end of the day, you end up making some progress. You end up moving forward, and now we're at the point where we have this entire interface that we no longer want to have because that was the thing that you used to target job listings when they came in. All right, so now that those targeting features are gone, I have the spec. Let me see if I can pull it up. And I'm sharing the whole screen that the spec is on, so y'all are going to see some stuff for a second. Do 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 do. Developer roles. All right, there it is. Okay, let me bring this over here.
Let me take our bonfire chat room out of there. The one that's now showing.
I'm bad at
Okay.
that. That's the problem with sharing two screens. Whoops. Anyway, back on point here. So basically, I have this spec, and the idea is like, let's see if we can zoom in on this a bit so people can actually see it. Okay, the way that this works is we have these things called tags and we have keywords. Keywords are really just title words, and then they map to a developer role. All right, so the idea is some of these things you'll notice don't have tags at all, and some of them don't have either, right? Like if you want to be a desktop developer, and don't ask me how we're going to solve that one, we'll get around to it at some point. And so what we want to do is we want to basically fill in all of these things that map to these tags. And instead of using these hard-coded lists, instead we'd like to do something a little more like MLE. So we're going to basically come up with all of the models that determine whether or not this dev role is appropriate given the tags that are on the job. In order to do this, if you're still following along, I built a data set by going to our database and saying, give me the job ID, the tags that are on it, and give me the roles that are on it. Okay? These roles are all human-made to date, in the most bland sense I can possibly say. I expect to learn for some of these ones like graphics and game designer that these things are going to map to this almost directly, and we're not going to learn an entirely large amount, primarily because the way that the system works is it looks at the header, or it looks at the title first, then it looks at these sorts of tags, and then there is another thing actually below this, which is how did we target it automatically. So like, okay, quality assurance, system administration, and these are the hidden things that you normally can't see. And since I don't actually have these for the jobs, it doesn't really matter. But this is the task. And that's it. You should be aware that jobs can have up to 5 tags, and they can have up to 2 different developer roles. And so what we need to do is, for any given role, we want to predict how likely it is to be the solution. So I got started yesterday, and I'm going to share what I got. I'm going to shrink you just a little bit so we can actually see it. Here we go. I got started yesterday. What we're going to do is load up, we're doing all of this in R. The reason we're doing this in R and not in some other language is because that's what we use here internally when we're doing modeling that makes its way to production. So I'm going to take and load this CSV up, and then we're going to do a little bit of transformation. I'm not even going to worry about this line because it doesn't really matter. All right, what this does is it says, give me all of the data that we just loaded up, and if we want to look at it, we see that it's literally just the stuff that was in there, but it's split out into different fields. When you use tidyverse, you are basically working in a thing that's called a data table, or a tibble, is I think the preferred terminology now, which you can like data frame, sure, yeah, and you can effectively mentally map this to the concept of a like a table in a database. Like each column has a name, rows have IDs in a sense, in their row number, and then the fields can have different data types. So in this case, we have a double, and then we have a couple of string fields. And what we want to do is we want to basically extract this out to say like, okay, give me all of these tags like separated. At least this is the way that I went about it. And maybe you can help me with this if you want to change things up. In this data set, we have about 78,000 jobs, a few over 78,000 jobs, which hopefully is enough to predict some of these things. I'm not sure if we'll get all of them, but we don't need to. We only need to get the ones that we don't have any information on. right? Like, I don't care that we can't figure out game development because we've already got something for game development. The DevOps thing, maybe we can come up with some technologies that are a little bit better, which would be awesome. Um, and then if we have other ones like product manager, I doubt we're going to come up with anything here because only 1% of jobs are tagged product manager. Stuff like that. But let's get into it. All right, so the first thing that I did was I said, give me this data frame, and then we're going to take the roles and we're going to split the roles based on spaces and basically expand the number of rows in this so that each of the set of tags maps to only a single role instead of multiple roles. So if we had one that had two roles, like for instance, if this one right here had two roles, we would just have two rows in the resulting data frame. And then we're going to do the exact same thing for tags. And this is basically going to put this into a much more tidy way of looking at things, although not perfectly tidy here. And then I also filtered just to clean up anything that had missing data because that's not very useful for us. All right, the next thing is I'm going to grab the job IDs that we're going to use to separate this into a couple of different sets here. I'm going to take the IDs and take 80% for our training set. I'm going to take the rest. Well, we're going to build the rest of the training set here. Training samples is basically just saying give me all the rows where the job ID is in the training sample. And then we're going to say the tags that are in the model, in the training part, are the only tags that we're going to keep. For this, I decided to basically take the training samples and then count the number of tags. And if we just look at this, and well, you can go like this, right? View. And take a look at this. Oh, got to arrange it. It's never as easy as you want it to be. Arrange descending in.
And second argument to count is sort equals true.
Oh,
that's a good way to do it too.
Okay. Let's try that because I actually like that better. See, these are the little tips that I... Oh, man, there you go. And I like that it even puts it descending. Okay. So basically what I did at this point was I was like, at what point do we run into, like, the amount of information that we're gaining from this is just not going to be particularly valuable? We tried it yesterday, and we had about 7,000 different tags. And the issue with that is, one, it slows your training down, and two, a lot of these tags don't provide, like, interesting data or don't provide any signal to the training that you're doing. So basically what I did was scroll down and I was like, okay, somewhere around, 1,000 seems like a good small number of tags so that we can still learn enough from it. And where would I get to? And I was like, okay, here's a good cutoff point because if we cut it off at 15, it's right around 1,000 tags. And that was literally like the thought process that went into this. There was no like modeling or anything like that. It's just your learning goes a whole lot faster if you can shrink the size of your data. And that was the goal here. But still keeping 1,000 tags is quite a good amount. So I don't even need this arrange anymore. Look at that, man. I'm just having such a good time now. All right, and now we can just take all of these tags. Uh-oh. What did I do wrong? Oh, I got rid of this pipe. All right, so now we have the model tags. There's 1,005 of them. And then what we're going to do is we're going to filter down our training samples to only care about the things that we care about. And the labels we're also going to pull out as a separate thing because it's going to make generating the list for training a lot easier. All right, same idea now. The test IDs is we're just taking a diff from the training IDs from the all IDs, and that will give us the remainder of them, so we don't have to worry about that. And then the same idea here, we're doing the filtering so that we're only taking the test IDs and we're also only keeping the tags that we care about, because although the other tags are going to be there, they're not going to be used in the model, and it's just saving ourselves a step later, effectively. Test labels, same idea, just pulling them out. All right, now is the part where like let's start talking about things. So I'm making I have the training samples and the way that they look, training samples, is we basically have a job ID to a role to a tag, right? I know that for the training part, we only care about the tags, and the like conceptual model that I have right now is that we're going to have one column for each tag, and that is going to be the input, and the value for a job ID to however many tags, and then we eventually have whatever the label is at the end. The value is just going to be a 1 for any tag because jobs can only have a single tag one time. Is this all making sense so far?
So yeah, so we make a matrix, and every row in the matrix is a job, and every column in the matrix is a tag, except for the last column, which is the label,
Yeah,
or would be the label for whichever label we're trying to predict.
correct.
And we're gonna build a classifier for each possible label.
Exactly. That's
So the
that.
whole left-hand side of that matrix is the same over and over and over again. And then we're going to flip out that last column to be if it's a front-end dev job, or if it's a back-end dev job, or if it's a DevOps developer job. And we're going to do 3, 4, 10, however many labels we have matrices,
Correct.
and train classifiers for all of them.
That's right. And then like on the step of like this thing is in a production environment, we're going to run this through each of the models, then we're going to just choose the one or two, that pop out as the highest, maybe have some sort of a threshold for each one, whatever it ends up being.
Yeah. So there's stuff like when you have multiple classifiers, you can use, yeah, you do one versus all, right? Or I forget what they are. One versus all,
I always felt like one versus all was, well, that's sort of what this is in a sense, right?
right?
Like,
Like if we run if we run a job through all of these, right,
yeah,
and are trying to find the first few labels, maybe we just pick the highest predictions out of each
correct.
classifier,
Yeah,
right?
yeah.
Um, uh, but sure, great,
Okay.
let's go.
Okay. So there are tools for making a sparse matrix directly from a data set like this, and I chose not to use them. Instead, I decided to do it by hand because I didn't go and look up the library for it. But I think is it like drlib that does one? Because maybe we ought to just pull it in. It'll read a whole lot easier. I want to say, oh no,
No, it's not
Silgalib.
drlib. It's ydr.
Oh, Whiteier. Is that
I
already
think.
loaded? Did I get that one for free? Tidier? No, I didn't get Whiteier. Let me get Whiteier.
Nope, it's in tidy text.
It's in
It's in
tidy
tidy
text.
text.
Okay. Okay. Tidy text it is. And now it's just cast sparse, correct?
Yeah, and you just have to look at whether you're uh, the terms they use are document and term, I believe.
Okay. Now, because these job IDs are actual integers, what we're going to end up with is a lot more rows than I care about. And what I want to do instead, I think, is convert them over to being strings,
Chars, yeah, as
chars,
character.
and then it'll just factor it out whenever I do the cast sparse, true or false.
I believe so. And then at some point there's going to be a point where we do a matrix multiply, and you have to use the special sparse matrix multiply
Okay.
operator. That's, I believe, is, oh, I have to type it out. It's less than.
All right. So in this case, job ID equals what is this? Cast. How do I make this into a string? How to make an integer into a string?
As dot character.
That's right. As dot character of job ID. And maybe we ought to just do this earlier on and like hit them all. But for now, I'm not going to worry about that. I'm just going to do it this way.
You should do it at the sample processing
Okay.
time, but
Let's go ahead and do that. let's just say mutate job ID equals as character of job ID. And then we'll just rerun all of this. Ooh, that's not fast. Okay, now we don't need this. All right, so now the next thing that we want to do is say cast sparse, and the data is the training samples, the row is the job ID, the column is the tag, which is a horrible name, and the value is 1.
Yep.
And that should just work, correct?
Hit the button. If you get an error, it didn't work.
Yet, not yet implemented for matrix with type of null. Not sure I'm going to be able to debug that one. Let's take a look at this.
Yeah, let me...
Right, and this is literally how this works. You just get an error and you Google it. Tidy text. Oh, look at this. We're not the first people to have this problem. What does Julia Silge, Dr. Julia Silge, say about this problem?
Our doctor.
Looks like a start here, unfortunately, for debugging. Having many PDFs. Oh, I think I see your issue now. When you are finding the term document matrix using cast, you need to count up the words in each document and then tell cast which columns belong to the word. Damn, now I have to understand all of this. Okay, doc ID, text, data words, unnest tokens, anti-join, cast sparse. Word doc ID in.
That's cast TDM.
Right. I've faced the same error. I almost feel like we could just ask her.
Don't do that.
Okay.
Okay, wait. So show me your frame again. Show me your data frame.
Yeah, my data frame is training samples. And we have char, and what we're using is this job ID and this tags.
Sorry, wait. Roll. Oh yeah, and you said training samples, cast sparse, job ID.
Do I need
tags 1? You got. I think you have to get rid of the role. You have to get rid of the roles. So select minus roles.
Negative.
Maybe. Nope.
Yeah, that did not work. See, and it was stuff like this that I feel like I sort of made this choice for.
No, I mean this should work. The library doesn't work. We got problems.
Not yet implemented for matrix with type of null. Let's just do. Let's do tidy text. What is this? Cast sparse. This is a fairly persistent issue, it appears. Did I just find the same one? I think I just found the same one. I did find the same one. Halted. Can you run the code below?
I mean, this was a long time ago. Do you have a really old tidy text?
I can't imagine I do, but let's go check it out. Packages, because I feel like I had to update it the very last time I tidy text 121. No, tidy text 020, maybe. Update. Let's do an update. Everything is fast. Am I on the network? Because I believe I am on the network. There we go. Tidy text. That doesn't seem like a big one. Might as well try it.
Yeah. I don't know what's going on there, but yeah, I mean, definitely be on the latest. Yeah, okay, that's select minus roles. That was a dumb idea. Get rid of that line. That didn't work.
I won't say it was a dumb idea. Oh, wait, it's installing now. Okay. So anyway, once this happens,
Library again.
hey, thank you so much for the follow. I really appreciate it. Marwankus?
Marwankus one.
Okay, could not find function. I guess I'm gonna have to redo all of this here. Let's just do it all. We'll just do it all. I am past where I wanted to be. Okay, so we still got the error. Training data. You know what? For the sake of time, we're just going to go back and we're going to do it this old way that I was
All
doing it.
right, yeah, forget cast bars. It's garbage.
So do I need, maybe I need it to be a factor. Maybe that's the problem. Like, do I need the tags and the other one to be a factor?
What if you just didn't change it to an int? Or sorry, what if you didn't change it to character?
So the problem is that,
Cast sparse should still work.
all right.
I mean, I realize it doesn't work right now, but
And the moment of truth. Ooh. I'm just going to mutate these real fast and see if converting them to factors solves my problem. Job ID equals as factor, and then as dot character of job ID, and tags equals as dot factor tags. And I can't imagine this is going to be fast. No. Alright, that doesn't work either. Alright. Just going to put this back in here.
yeah, go back to the old way.
Right?
We'll figure out what's wrong with that later.
And we're going to just comment this one out. Oh shit, that's not what I wanted to do. Okay, so now what we're doing is we're saying I equals training samples job ID, match equals training samples tags. Actually, I don't even need to, oh. And then let's make this as, and then let's do tags equals as dot factor tags, and let's do job ID equals dot factor job ID. For those of you who are watching and think that this looks really weird that we're adding this twice, each of these actually gets executed one by one. So this first one will get executed first, then it will do the second one, then it will do the third one. So if you create like a new field on your data frame right here, you can then use it directly in the very next line of the same mutate statement. Oh. What is it giving me hell about?
Yeah, it's so weird. I mean, I just pulled up all the Jane Austen books and got cast sparse working very quickly. So it's It's real weird that it's not.
Interesting. All right, I think I'm going to wait. Yeah, I think I'm going to wait to do this until after. Okay. Training samples. Training samples, all data, model tags. And then I want what? As.factor. That would be way too easy.
No, it's just factor. Oh, as that factor?
Yeah, why would it not be as? I don't know the difference between like using as and just saying
Sorry.
factor.
No. So you have right. So we're using the pipe there.
Mm-hmm.
That's saying
Oh yeah,
pass
pass
everything
n.
as the first argument to
Right,
factor.
right,
Even
right,
though
right.
what you really want is dot dollar tags and then
As.factor of the whole thing.
yeah, that's
Whatever. It's about making it work. Figure it
yeah.
out. Okay, so we have factor of the model tags. Now the problem is that I need to filter this and convert this to a factor at the same time. Is that even possible?
Filter tags in model tags.
But model tags is now a factor. Like, will it allow it to look at strings and
Yeah. I mean, why did you think you needed a factor in the first place? I'm sorry.
because I was already going through some hoops later on to like give the tags IDs to tell which columns they were, and just having it be a factor and setting it equal to the names should take care of that.
I see.
You see or you agree?
See what you were doing. Okay, so you want to give a number to every tag
I guess
in order to be able to pull it out of the columns, but the columns should be if you, oh, I guess if you had an actual sparse matrix, the columns or the columns should be tags.
yes.
You shouldn't need a tag number. You should just be able to look up that, like using subscript notation to look up, like you could look up a column by that string.
Okay. Okay, we'll try that then.
And again, if we had cast sparse working, where's this data?
This is it. You're looking at it.
I mean, where's the CSV? Can I actually pull the CSV?
Oh, yeah, sure. Let me drop it. Give me just a moment here. Let's go to. I'm gonna put it on our favorite box in the data team folder. And then where did I actually put this on my machine? I put it in datasets,
Favorite
dev.
box. Favorite box.
You know, the one that you
Data
need to
team
do
folder.
things on?
The ML box.
Nope. The one that you would.
The the remote desktop protocol box.
That's the one.
Okay. All
It's
right.
jobs to dev roles. This is fun. So you can only do this kind of sharing when you're actually working with the person that you're streaming with.
On C.
In the data team folder on C, yeah.
Data dash team. Data team.
Data dash team. Should get autocomplete if you're doing it right.
I'm. I am.
Never been on that box.
I have never been on. I have never shared a drive to
Okay,
this box,
I
so I
should have
can
been
actually
more
pull it down from my
specific.
Mac.
It is my favorite box.
Mac Exchange. Do do do. Wah wah.
Okay, so just to keep going
Yeah,
here.
yeah. Oh, data team. Okay, perfect. Jobs to roles.
Yes.
Okay, jobs to roles. CSV. Reader. Read CSV. Hey, okay.
I,
Jobs to roles.
I still have like issues here.
Jobs to roles. Unnest. Tag. Unnest tokens. Tag tags. Cast sparse.
I don't need factors,
Job
you're right.
ID tag. Yeah, cast. I mean, look, right? Like this is me. We should just do this on my machine where it works.
Fine, man. Share your screen.
I'm just fucking with you. A window.
I'm gonna have to make you bigger here 1 second. Bloop,
Share.
bloop. There we go.
Let's clear out all those plots. You all need to see that.
Maybe
Okay,
a new
so
session?
I got, yeah, all right, fine, new session. You're right. Session, new session. Where's this window going to be? Oh, right there. Sounds bad. Dink. A window. This window. All right, brand new session. Library, tidy text, library, tidyverse.
Any chance you can zoom in on this?
I can do that.
Yeah, there you
Yeah,
go. Yeah.
I can do that. I don't know. Is that look all right?
Yeah, I think that's okay. If anybody in the chat wants it to be larger, just let us know.
Jobs to roles equals reader, read CSV. Desktop jobs to roles.csv. Okay, so read it in. It's there. We want to unnest tokens, tag tags. So now we have a row for every tag job ID combination, and the roles are duplicated. And now we're going to say cast sparse job ID tag. Yeah.
I am
So
losing
now
my mind.
we have a sparse matrix, which is which has a whole bunch of different column names, but some of them are JavaScript, React.js, XSLT. They're the tags are the columns, and the job IDs are the rows.
Let me try this unnest tokens thing. I was going the long way about it. See, this is one of those things. I had all of this going like this. So, unnest tokens of tags.
Unnest tokens, the first argument is the field you want to unnest into. So I'm calling it tag because that's a tag.
Sure.
And it comes from the tags field. And the defaults here are pretty good in that it will try and space delimit whatever you pass it.
Okay.
So
let's try this now. Let's try this. Let's do all IDs. Let's do all data.
we can't see what you're doing, but
Oh, that's right. Gonna have to shrink you again.
that's okay.
Okay, so I'm trying the exact same thing that you did. I just replaced everything with unnest tokens for tag and tags, and then I'm saying basically everything else was the same here. Job ID in. This model tags I'm not going to do as a factor because I don't care about that anymore. Oh, tag. That's right, it's tag. Count tag. There we go. Training samples. Gonna have to
Those are
change that
tag,
everywhere.
tag and model tags. Yeah.
Okay, training labels. And then this one I need to actually like unnest token roles, right? Un
I guess there could be two.
there are.
Is that
Yeah,
true? Okay.
not even a question. And then roles. So same concept here. Okay. Take a diff. Tag in model tags. That seems to work. And then again on here, unnest tokens of role and roles. Goodness. All right. See, now we're cooking. Hopefully. I know. I talk like that. I literally do talk to myself. When no one else is like with me, I say things like that out loud. And then occasionally when I'm like with other people, I still say it and I'm like, ah. Actually, I'm going to keep that there for now. Okay. So now we shouldn't have to do anything. We should just cast sparse, right? On training samples and tag.
Training samples. Show me training samples.
Uh,
New session. I don't know. It feels
what's
like it
your
should be working.
version? I mean, what version are you using?
I'm on the old version. I'm on point two.
I'm like losing my mind. That's the same thing, right? Char, JavaScript, React, XLST, 14.147.522 double. Unnest tokens, job ID. Tag. Oh, I have a 1. What is yours?
Mine is nothing. I don't have that.
What does it turn into when you cast sparse? Maybe that's my whole problem here.
Oh yeah, it does not like that one. Get rid of that one.
Okay, but what does it turn into? Like, did it just turn my like developer role into the value or something? Oh no, it just made them ones. Okay, well that's
Yeah,
super convenient.
does what did what you wanted. I don't know why that. I don't know why that happens.
Like, what if I wanted them to be twos?
Value column name to use as the sparse matrix values as a string
Oh, it's
before
looking for a
sample.
name. It's looking for a name. That's the whole problem. If I had like just appended a new column called value and
Oh,
then
so if we had done this, okay. So if we had said mutate value.
you're in a different window. And also, no one can see what you're doing. They can only see what I'm doing. But yeah. Okay, all right.
All
So
right. If you had said mutate value equals 1 and then put value here, then you would have gotten what you wanted. But not a literal. Okay, fine.
right. Okay. Wow, that makes so much more sense after you try it 55 times and fail at
Yeah.
54.
When you figure out what your actual fucking arguments are,
Yeah.
it helps you do the programming.
I mean, it was called value, and I was reading it, and I just didn't like put two and two together. That it was just like, no, I need a column
All
name
right.
because the error wasn't like I need a column name. It was like something.
So, once again, here's your lesson of the day. It's your code, it's not the library.
That's usually the case. Yeah. Okay. These are the all roles. The reason I went with these is because I need to create a model for each role.
Yep. So you're gonna just
Eventually.
say, so you're gonna say like column one,
Yeah.
column two, column whatever out of that for the
Right.
multiple classifiers.
I mean, so basically all of this training stuff will end up making its way into some sort of like a function, and then we'll just call it with each of the different roles. Is
Yeah.
sort of the plan here. Okay,
Yep.
so what we have now is train. All right, so this is another part where like maybe we could use some help, and this might have actually gotten a lot easier here since we now have a sparse matrix. Can we get like in rows of a sparse matrix? I guess it would be dims. dim. Nope. That would be way too easy. Dim. Oh, dim. Okay, dim of. What is this? Training data. And we want the first one.
Yep.
Okay.
So you want to sample. So, okay, so what do you want to do? So you want to sample one from, okay, so we know 62,567, right? That's our top end.
No, this is fine. It has the correct number of rows. I need to now make the labels. That's what I'm looking to do. So what?
Okay. So the labels, okay, so the labels you need another vector with 62,567 elements,
Yeah, so that's what
right?
this one is, right? Repeat a bunch of zeros, or can I actually put the label in there? No, I can't. It's either a 0 or a 1, right? It either has it or it doesn't. Or can I do true and false? Because I like true and false. I'll
I
just do
don't
a
know.
0. I'm going to do a
I
0.
can't remember what GLM wants, if it wants one or if it wants true.
Okay, we're just going to go with zeros. Um, job IDs front end. Okay, so this is
Okay.
basically.
So
Go.
which one is front end, right? So you want to go to your all labels matrix and figure out which column is front end developer, but you should just be able to do that by saying all labels bracket front end developer, comma, or the other way. Yeah, no, the columns are in the second dimension. So if you say training labels, sorry, if you say all labels,
I don't have all labels. Oh, I do have all labels. Look
you
at
do have
that.
all labels. You made all labels, right? So say all labels,
Okay.
and then just open bracket, comma, front end developer.
No, because this isn't broken out. This is like job ID role, job ID role, job ID role.
Oh, you didn't make a sparse matrix of this.
No, I
I thought you
didn't.
did. I
No,
thought
let's
you
go ahead and
did.
do
You,
that.
you
You're
unnested
right. You're right.
tokens
That's the way
role
to go.
roles.
Yeah, let's do that. Let's do that. Oh, I did, didn't I?
So
Where did I?
test labels is unnest tokens role. I guess you also did that for train labels.
Oh, sure. Yeah. Okay. Let's do that. So I think we have training labels. Ah, it's in there twice.
Training labels.
I can just distinct
Oh yeah,
this.
and you haven't done the. It's in there twice.
I just
Why
distinct
is it in
this
there twice? It's
because
in
we
there twice
split.
because we unnested tags.
Correct. So let me just
Um,
distinct these.
yeah.
And then training labels, same idea.
No. Distinct. Yeah, distinct is fine.
Okay. Training labels, test labels. Now we have our training data. Now we don't care about. I guess we do sort of care about these. I think the real way to
Okay,
do
so
this
you
would
want to
be.
make so you want to make a label. You want to pull out a label column, right, from everything. So
What the fuck? Training labels. There we go. Okay, so now I have this thing has the correct length, and I want to say. So basically, all labels. No,
training labels,
training labels.
open bracket, comma.
I want to look at training labels.
Sorry, didn't you cast? Where did oh, you unnested, but you didn't cast sparse.
Ah, yes. Okay, okay, okay.
So just cast that sparse the same way as we did, right? Job ID role, and then each column will be the
Job ID and role.
yeah. So now each column is the labels for that classifier that we want to build.
Okay. Training labels. There we go. All right, and it just assumes that anything that's missing is a zero. That's correct?
Yes, that is a sparse matrix.
Okay, perfect. So now we have our data in roughly the correct way. So I don't actually need this anymore.
Yeah, so now I think you have one more question, which is what are the dimensions of that training labels matrix?
Great question. I think it's however many training labels. Yeah, that's correct.
Are they in the are the labels are the row names in the same order? Is the second question.
Very unlikely. Well, no, actually, I
Well,
think this
just
would be
test it.
likely. Yeah, how do we do this?
So you say row names of training data equals, double equals row names of training labels.
Um,
Hey, all right, just mean that, and if we get a one, we're good to go.
okay, I think I'm gonna leave that line in there because,
Woo! Something works.
right. If what is this cat? S-
Yeah, cat or print or
Stop
whatever.
here, cause it's broke
Not equals.
and not equals.
No, I'm not.
Yeah, no,
You
I
need to
got it.
change the.
Okay, so it didn't run that. That's awesome. All right, so they're in the right order. Now what we need to do is say training data and training labels, dollar sign. That would have been way too easy.
Training
Can't actually
labels
do that.
brack comma
Yep,
of, so what do we want to train?
front
Front end
end.
developer, right?
That would be our first one. Front end developer.
Is there two D's?
Let's go.
Yeah, there we go.
Row names of training labels. That's not what I. That is not what I asked for. I wanted call names. That's what I wanted. There we go. Okay, front end developer. All right, so now let's do some learning. We're on to that step. All right,
All right,
CV.
so training data is our matrix, and then we have training labels, which we're pulling just the front end developer column out of,
Correct.
and asking this to so what is so have you talked about GLM net, any of that stuff here?
No, not entirely. So GLM stands for Generalized Linear Model. GLM Net is a package that implements a number of models for generalized linear models. And when you do the CV dot, it means use cross validation when you're running this. The training data is the first thing that you want to send in. It does not have to be a binary matrix of ones and zeros. It can be something much more interesting with values, but effectively you're passing a matrix in here. On the labels, you're telling it the correct answers, the way that it should label them, because this is because well, the way that we're doing this right now, this is a binary classification. If we wanted to do a multi-class classification, I'm not entirely sure how to do that using this. Something we could look up. By saying family equals binomial, we're telling it to use logistic regression. There,
Which is the binary classifier.
yeah, correct, correct. I would draw that, but we're not going to waste the time on that. And then in folds here is because we're using cross validation. What we're doing is we're saying take all of the input data that I give you, break it into 10 different groups. You might want to stop sharing your screen, by the way, so they can actually see you. Break it into 10 different groups. Take 9 of them, treat it as the training data for one sample, and the other held out group, that other 10%, train on that 90%, then test against that 10%, and then record what that test against that 10% is. Then we're going to do that 10 times, and each time we're going to hold out a different group of data. You know, the first 10%, the second 10%, the third 10%. And then what we're going to do is we're going to average the results of all of those. So now, instead of running one model and getting sort of lucky, what we're doing is we're creating 10 different models and we're averaging them all together, and we're saying that you can roughly expect to get this amount of performance out of it. Then what we do is we take the one that did the best, and as part of this, also generalized linear model like GLMNet here is also using regularization by default. I believe it's using elastic regularization by default, which is a mix of type 1 and type 2 regularization. But
L1,
L1
L2.
and L2. Those are a little bit out of scope for the discussion that we're having here because I care more about whether or not we can actually do this prediction, and then we'll get into the details of that if anyone is interested. Woo! That's it. Also, please do ask questions. If you have any questions, more than happy to stop and answer as long as we're on topic here. All right, so now this should hopefully not take that long because we're not putting an enormous amount of data in here. We only have, 62,000 rows and, 1,000 or so columns.
Yeah.
Yeah. So it shouldn't take that long. Famous last words. Let's just do model.
Hit the button.
Yeah, let me do front end as a little bit easier to read here. Oh, that was weird. Did you see that? I don't like that feature where if you shift tab back to the beginning of a row, it just quits doing that line. Okay. All right, so this is not an enormous amount of data. It is doing the training 10 times here, so it is going to take a little bit longer than if we had used, like, say, 3 folds. And that's one way that you can speed things up. As a practitioner of like machine learning models, you should understand that shoving an enormous amount of data into one of these things is usually kind of a waste of time, with the exception of like a few very specific problems. Like for something like this where you're just passing in a bunch of tags and learning one label out of it, you're just not going to gain an enormous amount of benefit from having a much larger data set. All right, yeah, see, that didn't take that long.
All right, I'll be right back.
Sure. Now I'm going to plot it, and we'll just go over the plot until he gets back, and then we'll test the accuracy and whatnot. And the way that you do this is you literally just type plot model FE. Okay. What we're looking at here, and let me zoom this up. What we're looking at here. Bloop, 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 bloop. Oh, screwed it up again. Made it too big. All right. So the lambda is the penalty from regularization that was used. And what these numbers at the top are the number of parameters that went into the model. And what this is saying is that we can throw away even more of the input parameters than we tried to. The absolute minimum is this left bar right here. It sometimes is on the right, but in this case you can just look down here and see that the dot is lower than the dot right here. And so what this is saying is we can maximize the accuracy of our model using this number of parameters. In fact, as we add more parameters, you see that the error actually goes up. That's because those things do not provide enough signal for the algorithm to learn effectively from it. And instead, they cause, like a regression in the learning. So you can get away with using, I guess in this case, it'd be about 650-ish parameters would be the way to get the best accuracy. And if that's not a problem for what you're trying to do, then you can go ahead and use that. If, however, you have like a performance critical sort of a thing, and you need to use fewer parameters, the second line right here is one standard deviation away from that. And you can see that by throwing away on the order of about 200 of the parameters, you get almost the same accuracy here. And then as you go down to like 0 parameters, you actually throw away basically all of your information. So for something like this, it doesn't really matter which one we use because this is going to run exactly when a job gets posted and usually never again on the same job. So if it takes a little bit longer, like a whatever, it's just not that big of a deal. And also, we're talking about 650 parameters here. That's just not a lot. That would take, I mean, less than a millisecond to run this, so it's just not that big of an issue. In this case, we're going to go ahead and take lambda min then. That's my selection. I don't know if you have other thoughts.
Yeah, no. This isn't the only way this graph can look.
Right.
Is the other thing to say. So this looks like a pretty well behaved graph, I think. There are other ones where you start sort of in the middle on the right hand side, and then you dip back down, and as you go up to the huge number of parameters, it blows out going
Yeah.
up. The blowout here is very, very minor. So you could just say use all 871 and you're cross-validated, whatever would be a little bit lower. But this is, using half as many parameters is
Less is more.
less at the same benchmark metric is
Sure.
better.
Yeah, I mean there are a number of ways that I've seen these graphs look, and they're not always like super like continuous either. Like they can sort of wobble around a little bit like as you go, and it's sort of weird how it plays out. But in this case, yeah, like he said, it is quite well behaved, and there's also very low error bars. So all things considered here, I mean I would just go with the minimum, and that's just the way that I would take this.
Yeah.
Okay.
Lambda min, lambda 1 SE, either one is fine.
All right, so that's what we're going to do. We're going to grab lambda min, and we're going to treat those as our model parameters. And all we're doing here now is we're going to take a look at the accuracy and see if we're doing a good job or if this model is complete crap. And honestly, I don't know the answer to that. We're going to learn this together. In R, the way that you predict things once you have a model is you literally just called a function called predict. You pass it a model, and in the background, the predict function takes this model and finds the correct predict function, which is normally provided by the same package that built the model. So I believe in this case, it's something like predict.glmnet is the thing that actually gets called. And then you just pass in whatever is looking for in that package. So we're going to pass in our training data because I want to check the accuracy against the actual data that we trained with. And then we're going to check it against the test data. And I believe there is a shortcut for getting the results. Isn't there a way to like get the accuracy without having to go this route? I know we have to do this in order to get the AUC, but I just feel like there was a way. Maybe if we just look at it. Model FE. What in the hell? Oh, model FE. Okay. Not entirely sure.
Here, let me look.
Binomial deviance, the call in 0. Yeah, I'm not entirely sure here. Maybe there's a broom tool that just spits out the answer. You know what? We're already in it. Let's just do it. All right, so what we're going to do is we're going to get the predictions, and then we're going to compare them to what we know are the real answers because we have the real answers in this case.
Right. So run predict.
Yay.
Okay, and train prep. Oh,
I didn't run
Model
this.
FE.
I didn't actually run that. Oh, it is
Model
Model
FE.
FE also. Model FE, Model FE. Oh, it's this one as well.
Model FE.
All right. So now we have the predictions from the real. I'm just going to put some space in here. All right, so we have the predictions and we want to basically look at the accuracy. So the way that we're going to do that is we're basically going to say train predictions equals the actual answers, and the actual answers we passed right into it.
Well, so that's not going to work. So train preds is
Oh,
actually
that's right. We need
number.
to
They're
like
numbers. They're numbers between 0 and 1. So we have to pick a threshold, right?
right. Oh,
Um,
that's right. Let's take a look at that. How do we pick a threshold? We're going to take Tibble, and we're going to look at predictions equals train preds.
yeah, make this a good table. So or make it a good table. Add on the actuals here as well,
Yeah, let me
right?
just do both of them.
Yeah.
Train predictions equals train preds, and then we
Train
want
labels equals
front end developer.
front end developer.
Yes, comma front end developer because you want the column, not a row.
Yep.
And then test predictions equals test preds.
Well, no, that's not going to work because the train preds and test preds do not have the same dimension, nor would I think you want to put them in the
Yeah,
same frame.
solid.
All
Okay.
right, so that's our table, and then so like yeah, just look at this, just edit or print it, whatever.
Train
Okay,
predictions.
so
Wait, can I just do this? I'm just gonna do this, right?
yeah, yeah, right,
Is that a column? It is a column, and it's a
yeah,
one.
comma, yeah, comma one, comma
There we go.
quote one, yeah.
Okay.
That's very weird. Okay, so we have all these predictions on the left. And if you took those and you plot a histogram of train predictions.
Trained predictions equals
So train predictions plus geom histogram. Predictons.
what do you mean train predictions not found?
Predicatons, not predictions.
See, I copy and paste. There we go. All right,
Yeah.
so somewhere it starts predicting that, some of these are true. Let's see what the real values are,
So what
right?
is it? So what is this? So what does this graph say? Right. So it says that our classifier says that um, it's scoring a whole bunch of things really low on this scale, right? Which we hope are the ones that are not front end developer jobs. And then all of these ones out to the right, if I was to pick a threshold, maybe I would say 10%. Or
Okay.
zero point 0.1 might be 1.1 might be a threshold I plucked out of the sky just looking at this graph,
Like,
because most of everything is to the left of 0.1. That's all the SRE jobs and the back end and the data science and all of that. And then all of this stuff over to the right is what we hope are the actual front end jobs.
right. So when you're
So how do you pick a threshold?
well, so we don't want to pick a threshold on this because this is the training data. We want to pick a threshold against the test data. But when it's training, it is actually training against 0.05. So it believes if we were to say, like, if we were to check the accuracy of the training, we would have to use 0.5.
I could believe that. I don't know what's actually going on inside
Okay.
GLMNet about whether it's using a loss between its prediction and a 1 or a 0, or if it's actually using 0.5 or not. My guess is it's a loss, but
Um,
neither here
sure.
neither here nor there.
Okay. All right. Let's go to check
So let's
the.
say we used zero point 0.5 as a threshold. How would we use 0.5 as a threshold here? So we would say the final prediction. So mutate that tibble to say final prediction equals train predictions greater than 0.5.
Train predications. Okay. And then let's say. All right, so now let's just store this. Get rid of this for a moment. Okay, so now we have some data we can play with. Training results equals. I don't want to say equals. I want to say, what do we want to do with this? We want to say. We want to say $train predictions. No, we want to say train labels equals training results. I can't type today. $final prediction, and we want to do a mean of this, and that will give us our overall accuracy. So it's like 91% accurate, which I feel like is pretty good, considering this is a fairly unbalanced data set.
Okay, so now what if we
Against the
use
training.
what if we use 0.4?
Sure.
I mean the accuracy for 0.4.
So we're going to run this and that. 90.6. Let's go to 0.6, right? The other side. Yeah, 90.8. I don't know. We can graph this. Can we graph this?
This is it. We can graph this. So this is the threshold picking problem. So there might be another metric that makes more sense to use here, which is AUC. So if you say library capital M metrics,
there is a.
Have that.
No, it's all right. Install packages metrics. Come on. Let's do one other thing, and let's actually let's do this with the test data, because picking a threshold based on your training data isn't going to do you a whole lot.
Yeah, that's dumb. That's dumb. I agree.
Test labels. I'm just going to call that scores. I'm not going to waste my time. We'll come back to that. Test predictions, final prediction, test labels.
Call it test results, not training results.
Right? That's another good one. Uh-oh. Error installing. No package called metrics. Oh, wait, no. Wait. Installing, trying, downloaded, success. Okay, we're good. So now I can say library metrics, and we'll come back to this in a moment. All right, we have test results. Oh, man. What the... Oh, I didn't actually do this. I didn't actually... Test preds? Yeah, I did. Oh. Did I? F. Maybe that's the problem. I have training data, but I didn't do test data.
Yeah, so here's the other thing that you're going to run into is I don't know if all of the test data covers all of the same labels. So when you do the cast sparse, you have issues.
That's fair.
So the way I would have done this would have been to take all of the data, cast sparse it into the matrix that we want, and then then I'd pull out two sub matrices of those by sampling from the row names.
Yeah, I don't like doing that, like on the surface. I mean, maybe.
Why not?
I don't like doing feature selection based off of test data.
Well, you don't. So the problem is you want the shape of the matrices to be the same, right? So when you start with a full matrix and you cut down the column names that are, I mean, maybe this is true. Maybe I don't know. The column names, you want the column names of the test matrix and the training matrix to be the same and in the same order.
Yes, I agree with that.
So if you start from a
You're
matrix
right.
that
Okay.
has all of the columns, then you have all of the columns, I would think. But it's still a sparse matrix, so I don't know if they remove columns that are totally empty when you do that.
Probably not, but at the same time, it's like,
You just have to work through it and figure it out.
okay, so let's go ahead and do that then. So we have taken all of the tags and we have all of the data, and we want to cast sparse on this, basically. True
Yeah.
story. Cast sparse of job ID and tag. And we know better now. And now I can't use all data, but I can do job tag. Actually, I just have all the IDs because there's one per row. Right? So I have
Yeah,
job.
it's the row names, right? So forget the IDs for a second because I don't think you're actually gonna have to do anything with them. We're gonna what you
Oh,
want. So you have all data, and then you want to make all labels, which is another matrix, right, with the same rows, and each column is the classifier type.
right. Unnest tokens, and in this case, we're going to do roll and rolls, and then we're going to cast sparse of job ID and roll.
Yeah.
I think I'm just like,
Oh, you don't
oh,
have
I
an
forgot
equal
the
sign. You're
equal.
missing an equal sign.
Okay. Okay, now what we're going to do is we're going to say row names of all data. Sample frac. Is that even going to work? Of course not. That would have been way too easy.
So row names. Oh yeah, just yeah, right. Because row names is not a tibble. Row names is a vector.
Whatever. We'll just.
Um,
Actually, I don't need to do this.
just say sample. Take out the tibble.
Job
Just put the
tags.
sample in front. Sample.
Job ID. Can I do it like that? No. Okay, but I can do it like.
No, that's also a vector. You need to say select job ID, and then yeah.
Okay. Now we have training IDs. Training samples is in job ID, and then I think
Okay,
in
so
this.
now you need to subset out of the matrix for this, right? So it's all data, not filter job ID. Now it's all data bracket training IDs, comma.
Oh yeah. Training IDs.
Actually, you have to pull out the job ID. Uh, yeah, doing that sample with Tibble is a little weird. So training IDs, you then need to say um, pipe to pull job ID on the previous line, line 22.
Line 22.
Line 22, add pipe pull job ID.
And what does that give us? Oh, just a
So that
vector.
gives you the vector so that you can use that for the subsetting.
Great. And then this will just work like this.
Correct, I believe so.
No, that would have been way too easy. You know what the problem is? It's not looking at names.
Oh, nah, this is where you go to char. Now you move it to char.
Okay, so I need to take the job IDs up here and change it to char.
I think.
We're just going to do that on the input side, right? Mutate job job ID equals as dot character job ID. Okay, all data. This one, this one, this one. Hey! All
All
right,
right.
all
All
right,
right.
all right.
All
Yeah, man,
right.
all right. Oh, what a day!
This is just getting the data. Now we have to
I
get the
know,
training in.
I know.
Right. But now, okay, so now do the same thing for test IDs, test samples. Sorry, you should also pull the training labels matrix out
Wait,
to
no, hold
have
on.
just those same training IDs
Wait,
as
no.
rows.
Now is when we need to grab the samples. Now is when we need to grab the tags. Then we're going to go back and we're going to filter all data down to only the tags, only the columns that we care about. Then we're going to reload training IDs in the exact or training samples and training whatever in the same way again. Make sense?
Yes. So all that's going to be is what training samples, and then
I can just use pull here.
Well, you just want to subset the columns the same way, right? The same way we subsetted the rows to get to split training test for job IDs. You are going to, after we do the lambda min game.
Oh, son of a bitch. Wait, okay, hold on. I need to do like row sums, no call sums, and then I need to sort the call sums.
Why sums?
Well, I don't have like a tidy data frame of tags and job IDs anymore, so I can't just count them up. We have
The model tags are the col names of all data,
I
right?
know, but I
Oh, and
want the counts.
you want the counts?
Yeah.
Yeah, col sums greater than. Oh, I don't know how you do that filter.
As long as the call sums have the same names in the vector, we'll be fine.
Capital S, I think.
Call sums of training data. Let me just do that and see what we
Or,
get.
or all data.
Hey, see, we got the names right there. Now all we need to do is like, is there a sort to call sums? Because that would make my day. Starting to think no. What are you talking to me for? I didn't talk to you. Phone. Did I say anything like Siri? I don't think so. Let's do a little check the docs on call sum. Please have a sort. If there's not going to be a sort, is there? Is it in base or is it in matrix? I don't know which one we'd be using. Who cares? Dims 1. No, this is not helpful. Okay, so yeah, so now all we're going to do is we're going to say we have call sums, and we should just be able to filter this. What if we make a tibble out of this? No, because we'll lose the names. Wait, if we make a tibble out of a vector, out of a named vector, do we get an additional row with the names?
Sorry.
It's okay.
Col sums training data. The question is,
How do we get only the ones that have 15 or more? Like, I want to just filter this. Normally, you would just subset it, but
yeah, so this is a named list, and I think if you just if you just do an as tibble, you might get the right thing. So call sums to, or not as tibble, just tibble.
just tibble. Let's just see if that works. Those names are gone.
Tibble.
Wait,
Okay,
how
so we
about
want
this?
named vector to tibble in R.
Value. Actually, I can just do tag equals names of training data. And then I can say,
Ooh, it appears that you can just bind rows. Okay, so if you bound rows on the table, that should work.
bind rows to what? Just do
Just
this?
just do it. See what happens.
Oh, Christ. No, those are column names. They just became columns. That is not what I'm looking for. Is there a transform? Can I like,
Oh, and
can I,
then gather.
oh,
Bind
gather.
rows, gather.
I want to name this what? Name, no, tag and value.
Tag count.
Sure. Oh. Okay. Now that's in a form we can use it with. Okay. And now I don't need this.
Filter.
And then pull tag. No, it's not in anymore. It's count. Look at that. All right, model tags. Okay, 879.
All
Perfect.
right.
Okay, training samples. Now what we want to do is we want to basically do this again, only we want it to be like this. And model tags. And then we want this whole thing one more time for test. And all data. Oh, wait, we need the other IDs. How do I get the other IDs? Set diff is what I was using.
I
Set
believe
diff.
so. Yep.
Set diff of.
All data.
How am I going to get that? What are my training IDs? How did I get my training IDs?
You sampled, right? Yeah. So it's just set diff all IDs, which is going to be row names of all data. Yeah. So set diff all. So set diff on the first set. The first thing you pass the set diff is
I'm just going
all
to do it.
row names all data.
Yeah, test IDs equals set diff row names of all data and training IDs.
Training IDs. Yep.
That gives us test IDs. Now we have test IDs.
And test samples, model tags, or sorry, test IDs. Yeah.
Okay. Woo!
Now,
We don't
labels.
need this.
We don't need that.
Training labels.
All right. So training labels is
We have all
stuff.
labels. Oh, this is easy.
Have,
Oh, this is
have
easy.
all labels, right? Yeah.
Yeah, yeah, this is easy. All right. All training labels equals all labels of training IDs, comma. All right. And then we want test labels equals all labels of test IDs. All right. Okay, look, now we have all the data we care about. Don't care about test IDs. Don't care about test samples. Don't care about this. Don't care about training data. Don't care about test data. Don't care about all labels. Zom Chicken, thank you so much for the host. I really appreciate that, man. I hope you're having a good day, and I hope you had a great stream. All labels. We don't need all labels anymore, do we? No. We got names. Okay, now the thing that we wanted to make sure of, we don't actually need to make sure of this anymore because we guaranteed it.
We did.
All right, model FE is training data, training labels. This should learn, well, it's going to learn something different because we did a random against a totally different set. Oh, no.
Training labels, training samples, not training data. Nope. Training, training samples, not training data.
Should call that training data, shouldn't I?
Do it.
I'm going to call it training data.
Call it test data too.
That is also a reasonable choice. Okay, one more time. All right. So, I do like the way that this is much easier to like understand. I am like
It's a lot less code too,
it is a lot less code.
doing it this way.
Yeah. I guess one thing that I don't like is that this in folds is already based on the training data, but really all of your transformation should happen within each fold.
Yeah, so your test data is actually, so sorry, inside, it's usually train, validation, and test sets, right?
Okay. Yeah.
So you train and validate, and the fold is the validation set.
Right. That's correct.
And then our test data is the, okay, after all of cross validation has happened and we have tuned our model that way, what's the final result?
Yeah, yeah. Okay. And it spit out some answer. Let's see what it said. Same thing? Roughly the same thing. A few more parameters this time, maybe. Well, not around 650 still.
Yeah, about the same.
Okay,
Okay, so,
back to this stuff.
and then, right, so now run it on the test data, which we can actually do.
Yes, which I just did. Okay, all right. All
Oh,
of that
oh
worked.
shit, oh shit, you just did it.
It's like,
All right,
okay, 30 minutes. That's all. 30 minutes. Let's see. That accuracy is roughly what I expected. Great. Let's take a look at the test. Well, we're going to pull that in just a second, but I'm going to do, all right, our test accuracy, the thing that we actually care about.
point 0.6, point 0.5.
Test results. Test results. Train labels. Test. This was dumb. That was stupid. Oh, what's up?
Oh, shiza.
I do love it when your test data ends up having better accuracy than your training data. That doesn't happen
Okay.
very often. That is
So
a
what? Do we really mean point 0.6 or do we really mean point 0.5?
oh crap. That's what I meant.
Throw those point 0.5s in.
Okay, that's better, and this should be worse. No, I'll allow it.
Even better.
I'll
All right.
allow it. Yeah.
So, so is this really the best threshold? How do we know?
Right. Let's go find out.
Okay, wait. So here's the other thing. Okay, so we added library metrics, and what we really wanted to do with library metrics was use one of the more proper metrics for this instead of accuracy, which is okay, right? Here's the famous classification accuracy failure, right? Did our model just predict 0 for everything and
Right.
get 90% accurate?
Correct. Yeah.
We don't
Yeah. Yeah.
know. So what do we do for this? We want to create, we want to use an ROC curve
Right.
to
What is?
to deal with this, but I guess we could do without the ROC curve. We could use metrics AUC, and that will give us more of uh, an idea about how good this is, because accuracy does not tell the story.
No, it does not. And in
So
fact, these are unbalanced classes. Like we looked up, and it was only like 7% or something like that was tagged front end.
right.
Right.
So let's look at metrics AUC, and the first, so actual is test labels front end developer.
Test labels, comma. You know what I'm going to do? I've typed this like 5 times. I'm just going to make it a variable now. I'm going to put it up here, and we're going to call this dev type.
Role.
Sure, role. Model role. And then we're going to replace this everywhere, because now we can just change it in one place, like moderately proper coding.
Let's not get crazy.
I don't want to get too crazy. That's why I said moderately. Okay, test. And then we also have test.
and the comma. So the predictions are
No, test
uh,
results. Oh, no, no,
test
no, no, no.
spreads, test spreads.
Wait, I'm gonna do this all from results because it'll make it easier.
Oh, yeah, sure.
Test
Test
labels,
results, bang, yeah, wait, exactly.
and then final prediction. Okay, 82%. Can I visualize that? Is there an easy way to do that using this, or do I need some sort of?
Okay, so you want to, yeah. So here's the way I do this. There's probably packages that give you ROC curves really easy, but the way I like to do it is with crossing.
Okay.
So what you want to do is, so what thresholds do we want to use? Let's say we were going to test thresholds from 1 to 100. So say crossing threshold
Wait, 1 to 100. I thought.
percent.
Yeah, 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 yeah. Okay.
Yeah.
Okay.
So use the range.
1 to 100.
So threshold
Let's just do one
equals
to 1,000. No, we can't do that, can we?
one. Yeah, no, do 1 to 100 over 100
Oh
is
yeah,
the
over 100.
is the
One to
form, right?
100
So
over.
we do a vectorized divide there, and call that threshold.
Oh, I see. And I would do 1 to 1,000 over 1,000. Okay, all right, this makes sense. And then what am I saying here? I'm sorry, I was talking and not paying attention.
So call that threshold. Crossing open paren threshold equals no inside the crossing. Name those that 1 to 100 threshold. Yeah. Okay.
Okay.
So those are our thresholds, right? So if you hit enter, we'll see a data frame with 1 to 100.
Okay, perfect.
And I guess it doesn't have to be crossing. Just say Tibble instead of crossing, because we're not actually going to cross anything.
All right.
Okay, so Tibble threshold. Okay, so now for each threshold, what we're going to do is evaluate all of the predictions about whether they were true positives or false positives at that threshold. So we're going to mutate.
I feel like there's a map coming.
There is a map coming. Map, so mutate stats, just say stats equals, yeah, value equals, whatever. We're going to unnest it later. So map of threshold.
Threshold. And then we need a function, is that right?
Yep, comma, tilde.
All right.
Okay, and so now what we want to do is take all of the test predictions,
Sure.
and we want
Test
to, and we,
results
or
predictions.
I guess you could use test results. Yeah, that's fine. Yeah, okay. So use test results and say test results mutate final prediction. Right. So this. So take final prediction out of the test results.
Take
Tibble. So on line 71, just get rid of that because we're gonna add new final predictions for each one of these thresholds.
right.
Right.
Sure.
For 1 to 100. Okay. So test results. And
That's not
yeah,
gonna work anymore.
we could do it for training too, but whatever.
Sure.
So we take test results, right? And we're gonna get rid of the dollar and test predictions, blah blah. We're just gonna do a mutate inside.
Okay.
So test results, yeah, get rid of all that. Okay. So the function is you're mapping threshold, not threshold.
It's threehold.
Okay. So what we're gonna do is say test results. Pipe mutate final prediction equals test predictions greater than .x
Equals test. I need test results.
No, just test predictions.
Yeah, they're in test results.
Yeah, but you're in that frame already, right? You're piping through. You're in
No,
a
I'm
test
not. I'm
results.
in Tibble. Am I not? Oh,
No,
yeah, yeah, yeah,
you're
yeah, yeah, yeah.
inside a
I see.
function.
We're in
You're
a
inside a
function.
function,
Right, right, right.
right?
test predictions greater than dot. Oh shit.
Greater than dot x.
Dot x. Dot dollar sign x.
Nope, just dot x.
Dot x. Okay. Well, this turned out to be kind of crappy with my zoom here, so we're just going to do this number. Okay, we have now mapped this, and so basically we have value, and that is going to return a new tibble for each one of these.
Right. So we're going to get a new. So inside. Right. So value is going to be a new tibble for each one of these things, and the predictions that are in the column inside each of those tibbles are going to be the ones for each threshold that we chose.
Okay.
So another thing, I think the final thing that you want to do in here is what we care about is calculating the false positive rate and the true positive rate, which we can do inside the map.
Sure.
So I'm gonna suggest we do that. Push that mutate down to the next line. The inner mutate. Sorry.
Okay.
So we know where we are. Okay. So now we're gonna take this and we're going to so what's a true positive? A true positive is where the final prediction is positive and the label is positive.
Maker images. Thank you so much for the follow. I really appreciate that. Okay, so wait, no, I want to do more inside this same mutate, or I'm piping this to a new one.
New. So we need, what we're trying to get is the true positive rate and the false positive rate.
Okay. So I can just do it inside the same one then.
So yep, inside this mutate, we're gonna say we're gonna add in. We basically want to mutate.
False positive rate.
Just say false positive. FP equals.
False positive equals.
Equals. Not final prediction. False positive is final prediction and not test label.
Final prediction, binary, right?
Yep, and not
test
label. Right, so this is, we predicted a positive, but the label is negative.
Test labels? Must be test labels.
Labels, it is labels.
Okay.
And then true positive.
I want to make this final predictions. Give me just a second here. Okay, and then true positive?
True positive is final prediction and test labels.
Final predictions and test labels. Okay, wow. Let's just take a look at that. All right, we got a tibble in there for each one of these things. That's got the true positives, the false positives. All right.
Yeah, so just take the head, just take head and head 1 and unnest.
Sure.
And we can look at what's inside that value.
Head 1. Unnest. All right, so we've got a threshold, we've got test predictions, test labels, final prediction, false positive, true positive. So really all I want is the false positive and the true positive.
Also, okay, so for this, so in here, what we have to do now is we need to sum up, because we don't care about the false positive that each individual one is a false positive or a true positive. We care that for this threshold, we need to know the numbers that are the false positive rate and the true positive rate.
All right, so group by threshold.
It's really, we're just really going to do a summarize inside.
Oh, yeah, right here.
So in the inner, we're going to summarize and we're going to say, I always have to look this up. Wikipedia binary classifier.
Is it just mean of false positive, mean true positive? No, wait. Oh, wait, no. I see what you're trying to do. Now you're trying to get the actual, okay.
Yeah, so what, Wikipedia true positive rate. How about that'll get me where I want to be. So the true positive rate is the true positives over all positives.
All right, now I understand why you did TP. FP and true P. Okay, and I'm looking for the
So TPR equals
TPR equals
is going to equal TP over sum of test labels.
over test labels. Why?
So TP, sorry, sum of TP,
Okay, yeah,
sum
I
of
was gonna say.
TP,
All right, I was like, this is a group thing. You can't have like a vector there, right?
sum of TP over sum of test labels.
Okay, and then we want the false positive rate.
And then the
False.
false positive rate is uh, false positives over all negatives. So sum of FP over sum of 1 minus test labels. Right? So that's false positives over all falses. And we have true positives over all trues.
Right.
And now, so now if you just run, if you get rid of that group I,
Hey.
you
Okay.
can, oh, I got a child. What's going on, child? Giannis? Yeah, that's fine. Go ahead.
Ah, man, she's getting so big.
She is enormous. So what do we got? So for our threshold, which is incredibly low, we have a very high true positive rate. We're catching almost all of everything that's actually a front end position, but we have a 68.8% false positive rate, which means we're in addition to our 100 almost 100% true positives, we have almost 70% of all of the other jobs we are also classifying as that.
Right.
So now get rid of the head.
ggplot is incoming, I can imagine. AES on the bottom is going to be the true positive rate.
Yep, TPR, FPR.
TPR, FPR. And so in this graph that we're about to see, and this is just a line, right?
Yeah, plus geom line.
Geom line. All right, so in this graph, what we're about to see is that
Nope.
no,
FPR, TPR. Always, you can
yeah,
always
yeah,
get it
yeah.
wrong.
FPR, TPR. All right, so in this graph, what we're about to see, all right, is like just give us a quick explanation here.
Okay, so this graph characterizes the trade-off that you make between being able to correctly classify only the true positives um, and and how many false positives that you get. So on the left side of this graph, we have a very low false positive rate, and if you go up to like 25 or 50, you can see that we maintain on the true positive
Yeah,
side, we maintain a very low false positive rate. So out of our 60,000 jobs or whatever, we're having, this is talking about maybe 1 or 2 or 3% or something being pulled in as false positives.
got it.
So 3% of 60,000 is 200. Yeah.
Yeah,
So so at that point, we would catch 50% of the jobs that are actually front end, and we would have 200 other jobs that are not front end. Now, how many jobs are there that are front end? Um, that's not, you can't really see that in this graph.
right.
Um, and unbalanced classes make this, a little bit hard to think about. But what did we say? There's something. Count up the actual true positives, so I can have a number. What did we say?
Sure.
7%, 10%.
Sum of test labels of test results, results of test labels. 2,814 out of What,
out of,
60,000?
well, I don't know, what
Oh
was in
no,
your
test
test? Did we split
samples.
it
Yeah,
50-50?
15,677.
How many?
15,677 totals, and then there are
Okay.
2,800 trues.
Okay. So there are 2,800 front end jobs out of these 15,000
Right.
all jobs in our test set. And so so if we go back to the TPR FPR graph, we can see that so to catch 50%, to correctly classify 50% of those actually front end jobs as front end jobs, we would only have to take 3% of 15,000 or something like that. So 3% of 15,000 is
1% would be 150, so 450.
yeah. So our classifier on this very bottom end here might be able to we would have if we use if we use the threshold that goes with that point, um, we would see 1,400 front end jobs, and mixed in with those 1,400 front end jobs, we would have
An additional 450 non front end jobs that we called front end jobs.
that were mistakes.
Right. Okay.
Um, and if you walk, and so if you walk up this curve, so where do you want to be on this curve? Um, it depends on your problem, right? If you can accept false positives,
Right.
um, then you can be further up this curve. If you cannot accept false positives, then you need to be
To the
further
left.
left to the left on this curve.
Okay.
And this, I mean, this is so logistic regression out of the box with no, we didn't do anything fancy.
Yeah.
Um, and we have an AUC, what did we say, 0.82?
What was it? Was it up here? I'm not ever gonna find this, am I? 0.824. Yeah.
Okay, so that 0.82, so what's the physical way to think about this? That 0.82 is the area that is underneath all of this curve.
Right.
Um,
All the
so
way. If it went all the way to one.
if it went all the way to 1, the area under this curve would be 0.82.
Right.
The maximum that you can have is 1.
Correct.
And that curve looks like a line that goes straight up the
And then
y-axis to 1 and then straight over. And the area under that curve is 1. This is 0.82. So we're 82% of the way to a perfect classifier. And
okay. So in this case, if we used, how do we choose a threshold? So this right here says the threshold that we're willing to go to. How does this work? Show me this. So we're on false positive, whatever. So what we need to do is figure out what point this is in terms of our threshold, but we don't have a threshold marker here.
yeah, sure. So add geom point and geom text
Oh yeah. Okay. All right.
and add the threshold as the label to the geom point. Or you
Geom
could just add geom text. Just add geom text. Geom text, AES, label equals.
label equals threshold.
Threshold.
Oh
And
lord.
you might need to make it bigger. Yeah, when you do the zoom and zoom it all the way.
Okay. So our threshold can be like, you know, ugh. Okay, it's kind of ugly. I'm going to be honest with you. It's kind of ugly. Um, maybe we can print out every other one.
Do you have geom repel? I don't think that's
Oh,
gonna look
yeah,
good
yeah,
either.
yeah. GG repel. I think I have GG repel. Plus GG.
Or you could actually that's a good. Your first thing was pretty good. If you just pick every other, just say like threshold over zero point zero 0.01 mod 2 equals 0. Yeah,
Threshold
no, you have to filter before the plot.
filter before the plot. Oh, I
Yeah,
got
so
you. I got you.
unnest pipe to threshold divided by 0.01 mod 2 equals 0.
Filter threshold. Oh, I got
Threshold,
threshold. Threshold times point. No, 100. No. Why
yeah,
can't I do this
threshold,
in my
fine.
head?
Yes, this is fine. Threshold times 100
Mod
mod
2.
2 equals 0.
Okay. Oh, crap all.
And pipe it.
Threshold. And pipe. Missing something, am I?
Is there anything in there? Oh, you didn't actually run a whole line. You've got a. Oh,
No,
that
I
looks like
got
it should be
I
right.
got something
Control
crappy going
Enter,
on here.
geom text.
It's not liking this. Weird.
Oh, it's a double. Is it double per? Is it double percent? I think it's double percent.
Oh, yeah, okay, sure. Let's see. Alright, I think that might have helped enough.
But that didn't do what we wanted it to do.
No, it really didn't, did it? 'Cause that would have been way too cool. Times 100. Mod 2. Maybe it's doing one of these before the other.
Oops.
Like maybe it's modding this first.
Oh yeah, do the threshold. Yeah, yeah. Okay.
And let me just, be super cool here. That's better.
Love that math. All right, 3. Right, whatever. Okay, can we read it now?
Yeah, all right. So here's point 0.5, right? So this is where it thinks the best. Well, that's where we had the highest overall accuracy. However,
Maybe.
well, maybe.
I don't know. I'd have to go test accuracy across all of those.
Okay, that's
Uh,
fair. Yeah, that's fair. All right. Well, that was a fun exercise.
so that was one, and that's one of the classifiers that you built,
Yeah.
right?
So we
And
need to.
you want to do the rest for all of the other labels,
Correct.
and then do something with that afterwards.
And then, find a way to like spit out all
Combine
those
them all.
models and put them somewhere. Yeah.
Yeah.
Okay. You know what? I think that's going to be it for today, man. We kind of went a little long here. Normally I do about
It
two
is.
hours, but we did 3 today. But it was a whole lot of fun. We learned a lot about you, and we actually got to.
What we were really here for.
Well, sort of. I mean, it's entertainment and learning at the same time. So, um,
Infotainment. Infotainment.
okay, I'll use that word. Maybe I'll change the name of the stream. No, I won't actually. I like my name, but good choice. Maybe you should choose that one.
All right, man.
All right. Now, I really appreciate you stopping by. That's it for today. We're going to go ahead and cut this off. Thank you, everybody, for coming to hang out. I really appreciate it. If you have any questions about this, do feel free to ask in chat. You can also ping us on Twitter. You can find me on Twitter really easy. I don't know. Maybe it's easier to find Jason wherever. I don't know.
I'm
It
on Twitter.
Sure,
It is
yeah.
my name.
At
Twitter
Jason
at Jason
Punyon.
Punyon.
There you go. And yeah, that's it. I will be back tomorrow. We're gonna keep working on this tomorrow. I'm gonna grind through the other 14 models, and we're probably gonna spend. I'll probably grind through the 14 models tomorrow morning before the stream, and then tomorrow we'll actually convert this into some C# code so that I can get my project done for this week. And yeah,
Oh yeah.
all right, that's it. Let's since we got a few people in here, let's go find somebody to raid real fast. We're going to go with. Let's go with Reverend Jesse. Relevant Jesse. My bad. Relevant Jesse. Here's how we do a raid. We click in here. We click on this person. We click the raid button. We wait 10 seconds for whatever reason they make you wait 10 seconds for. I don't actually have anything to spam when we get there, but just drop in, say hi if you want to. And again, thank you everybody for coming to hang out, and we will see y'all tomorrow.